Okay, so I'll be sharing my screen. Just give me a few minutes. I'll join. Good morning. Am I audible? Can
Yes, sir,
anyone
audible.
confirm? Okay.
Yes, sir. Audible.
Yes. Okay. So is my screen visible?
No, so your screen is not visible.
Okay. So
No, sir, your screen is not visible.
it is not visible. Okay.
Not
No, sir,
visible.
screen is not visible.
Okay. Okay. Just okay. I believe it is. Hello.
Yes, sir, it's visible now.
Okay. So can you see these presentation slides?
Yes, sir. Yes, sir, visible.
Okay. So let's start. Welcome to day 4, session 1. So today we'll be talking about some advanced tools and topics in this Python. So I'll be discussing briefly about some of the like libraries or packages. They are called packages mostly in Python. So there are some of them that we'll be covering in this session. Okay. So this is for discussions like so there is something called time module, there is OS module, and there are few special operator. Okay. which is called wireless operator, and then is this uh, matching thing, which is that I'll be discussing some interesting examples using this RE live. After that, I'll be showing some of the like basic codes and examples. So, okay, so let's start today. So first one is time module. Okay, so in Python, like time can be represented in various ways. So it can be represented in terms of as well or in terms of date as well. So like a date can be represented as a particular number. So the number should be it is an integer. It could be negative, positive, or zero. So it is designed in such a way that this first 1970 this date is designed at day zero, like time like 12 a.m. is designed at zero. So if we move from there to like to the right, like 2nd January and so on, 1970, it is positive numbers. But if we go to the past of that date, that those dates are negative numbers. So in this way, Python represents every time instance as a integer, not integer, like a large integer, whatever you may refer, like a big number, positive and negative. Anyway, it can be presented like that. Okay. So this is a special. Just you need to remember this 1970. So if you see, one day has this amount of second, 86,400. So if you multiply these three, 24 into 60 to 60, you will get this number of. So one year will have particular number of seconds. This 3153600. And if you see this January, this is so this first January 1912 AM is zero. After that, if we move to the right, like 1 year, like 1st January 1971, we'll be calling it by like because 1 year contains this amount of second, so number. And if I go 1 year into the this negative number, so every number is like every 2nd January 1969 will be represented by some other number, and every time also will be can be presented like every second can be explicitly presented. Okay, so if I calculate the day like the number for 1st January 2025, it is coming this. Okay, so let's start with few of the examples because otherwise it will be very difficult for you to understand. So I shared these all these materials with you, so you can open them. So I have shared a txt file. You can see the codes that I'll be talking about. Like you can copy that code in your terminal or whatever. Like if you are using Colab or Anaconda Simulator, anyone, so any library, so you just copy the code and the code will work properly. Okay, so let's start. So there is a special. So it is clear, right? How time is presented in. Uh, it's clear, right? The basic understanding at least clear. Can anyone confirm? Okay. Okay, thanks. So okay, there is a special term called epoch. So epoch is the point where the time starts and it is platform dependent. So in like Windows, Unix, and even in this collab also 1970 January 1st as time instance zero. Okay, and as I discussed, moving left and right it changes. Okay, so if I run this code,
Sir, please large your font size, sir.
okay, okay. So if I particular code this time, so you need to write import time and then like gm time. If I write zero, so particular number it can be presented by like this. So it is saying that so this particular thing, this time dot struct time and whatever in it is called as uh, tuple. Okay, so if it is like this, it is 1970. So it is a like Monday. Okay, time hour like 000 time. Okay, and there are more information like like which day it is and all. So like this. Okay, so if I change this particular number, so as I mentioned, like this particular number is this. So if I change from 0 to this particular number, I'll be just a minute. Maybe there is some 17 35 look like this. Okay. So if I do it, so this date will be changed to 2025. This first month, okay. This is day one, okay, and like which day of the week. So which day of the week is like it starts from 0. 0 is Sunday. Sorry, 0 is Monday. So the is 2 is it is Wednesday. So if we see the calendar, I believe it should be Wednesday, 1st January. Yeah, it is Wednesday, right? So this is how you can present time like this. Okay. So this is like a tuple. Okay. So this particular thing it is called as tuple. Okay. So as I previously mentioned, like if we go to the right hand side, like to the left hand side into the past, it is negative. Okay. So if I say this particular amount of time, it is 31st December. See 31st. This is the month. 12 is December and 1969. Like this. This is one day back, and 2 into this is basically 2 day back, and so on. This will go on like this. Okay. So it is clear, right? Whatever I discussed is a very basic thing. I believe this should be clear. Can anyone confirm? You can say in the chat as well.
Sir, why 1970 is chosen as 0?
See, it's how they have designed, like Python have done. There is no
Okay,
particular reason for that.
okay.
Okay, so if we want to do the current time, like what current time instance, you can do it using this time dot time, and it will print like this. This current time is this. It is presented as an integer. Okay, like not integer, like a decimal number like this. Okay, so it is not a very convenient way to like say what time it is. If you say this, no one can understand. So there are more ways to do that. Like you can like code it like this to there is this particular function called strf time, okay, which will say the current time like this, like 2025. This I will just read on 2025 and it's 4 a.m. here. So if you see, it is this UTC, like it is a standard time, like 5 hours and 30 minutes back. So it is, if you see the UTC time, it is 4:44. Okay, so it is coming like that only. So if you want to like see the Indian time here, so it can be done it by the local time. But the thing is, if I execute it in my local system, it will show local time like this. So so this is a code like, see, this is I'm running this in my local system, and this I'm running in the Colab. Colab is a cloud platform, which is like it is the server. I don't know where it is, but anyway, it if I type local time here, it will always like it will show this green like the normal time only, like the same exact same time here. But like if I add this particular thing hard coded, because I know I stay in India, so 5 or 35 minutes, 30 minutes is this amount of seconds, and I can do it. It's 10:15 here, okay. But you can, if I run the same code without formatting like this, adding this particular 5 hours and 30 minutes, it will show the Indian time as well, because it is running in my local machine. And but since this is running in cloud, it, so I have to do this. Okay, so so clear, right? No problem till now. Anyone can confirm? I believe this should be clear. Okay. So there are more ways to do that. Like you can present in other formats as well. So there is this function called C time, which will be presenting the time like this, and there are multiple ways as well. Like this, as I previously mentioned, this STRF time, which present it like this, and C time present it like this. Okay, so that is fine. So like you can also do it like the you can also put a particular integer, a particular number, any number you can put, and it will show the current time. So if I put the 10.2, so like 10.2 is basically that is coming in 0.2 millisecond, 0.2 second. So if I show the like 15, so if I see, if I am typing 15 here, it is showing 1st January 1970, 12 a.m. and 15 seconds. Okay, so if I increase it to some big number, so it will be increasing like this. It is January 3rd, 1970, and this particular time. So like this local time module, as I previously mentioned, like it do not work here, but it is a like the mean time, Greenwich mean time. Okay. So okay, it's clear. I believe it is clear till now. So also you can like you can present it like this as well, like strp time. So it is also the by default format. Like you can like present it if you insert a string, okay, like this, like Tuesday 3rd August 2021, and it will just convert it to this format as well. So strp time, this particular thing. Okay, so this is this again what it this function, it again converts this particular time to integer as well, this particular integer as well. So like these you can play around with it. Like you can present your time in like in you can give a particular number and it will give you like this. If you can insert the tuple again, it can give you this particular number. So if I see I am typing 513 here, it is presented in like this in particular tuple. And if
So
I am again inserting the tuple here, someone's micro is open. Can you turn it off? Okay, thank you. So, so yeah, if you can do it like this, it will again just convert it to this integer. Okay. So this is the basics of time module. So is it clear? Like time, there is one more thing that I'll be saying, but this is the more or less everything of time module. So I believe this should be clear. Okay. So now there is one special thing called sleep function. Okay, so sleep function, what it does, it just basically delays it. So I will be printing from 1 to 4. If I do not like sleep dot time, time dot sleep, if I do not press like do not code this, this is I'm just commenting this out, this will instantly print it. But if I say that I will be like delaying it, like, so what it will do is that, let's say, so it will print it will first wait for 3 seconds, after that it will print 0. Okay, so after 1, so it will go on like this. Okay, so you can like basically wait and do it. Like you can make your system wait for some particular amount of time. So it can be done using this sleep function. So one, again, also the delay is slightly lower. Okay, so more or less the time module. So I, this is a very simple module, how to use it. So I'll be discussing about some of the like applications as well at last, but these are the basics. So I believe this is confirmed. Okay, okay, thank you. It's done. So next thing is that we move into this OS module. Okay, so you can like if you have done this like you can just indirect directly with the OS, like make file, delete file using Python as well. These some basic functions that you can do using file handling. Okay, delete like path manipulation, like copying a content from one place to another. This can be done using Python very easily. So there are some of the examples that I will be discussing. Like I have like shared. So it's in this OS module and commander have it. So I have, so you have this txt version of this file. Okay, so yeah, so this is how you can do. So first one is this, you can show your current working directory. Okay, so if we run this, start in the session here. Okay, so this is done. uh, uh, Disconnect, delete continuous. So this is done. Yeah. So I'll be, so if we see the current working directory, if we just run it, so it is showing the content. Okay. So where, so this has access to my Google Drive, and like it is showing that it is like this, like the location is like this. So I mean this content, like inside the folder content, default access that you are given when you like code in collab. Okay, so if you see that there is one data, like well, there is one particular thing of sample data. If I press this command, so now inside the sample data. Okay, so if you see, this is my current working directory. Okay, so here it has some content. Okay, but yeah, I am inside this. So if I can also go back, like I can exit the folder. So previously I was in sample data, but now again I am in content folder. Okay, so now here you can just enter a particular folder, or like get out from a particular folder using uh, this command. Like OS is the module that you need to insert, and like get CWD stands for current working directory, and you can get your current working directory, and chdir, by this you can just move around. Okay, and by this you can, like you can like get out from a particular folder. So currently if I, so I am in inside content and sample data, and if I do this uh, I'll be getting out from this. Okay, so if we see, if I don't know if this will work or not, ls command, let's see. Yeah, if you see inside this sample data, there are six files, right? So since I'm in content, like sample data, just these are displaying the content of this particular file. These are some random files that I use maybe previously due to training something, some, but yeah, this is not relevant at this moment. Yeah, so this is how you can see where you are, like current working directory. Okay, so you can, like I am in currently inside this content. Okay, now if I again like so yeah, so this is saying I'm again
Sir, you are not audible.
hello, am I audible now?
Yes,
Yes, sir.
Okay, okay. Yeah, some internet problem is there. So were you able to display this ls thing? Was that shown, or it disconnected before that?
Screen is disconnected.
Okay, okay. Okay, so CWD is clear, right? Current working directory is clear.
Okay, sir.
Hello. Uh, like could you hear about working directory? Like moving from one directory to another. Was this concept clear? Like was it like my disconnection happened before or after that? Can anyone confirm?
Sir, please repeat again.
Okay, I'm starting from the beginning. Okay, so like this OS module. Okay, so you can uh, what you can do using this import.os. This is the OS module. So here like you can print the current working directory. So like this have access to my Google Drive, and currently if you see that I am inside this content folder. So after in the content folder there is one particular folder called sample. So I'm inside this sample folder. If you see, so if I press ls here, this will print this content of the sample folder. Okay, like sample data folder. So these are the for content here. So you can like get inside this folder as you can yeah, you can get inside there, and you can get out of here as well. So if I get out and again press what are the contents here, so it is saying that there is a folder called sample, like this. Okay, so ls command just basically list all the content in a particular folder, and yeah, you can change the like where your location, like this, like chdr. This is the particular command that you should be aware of to like change your position from one directory to another. Okay, so now currently you are in this folder, but anyway I'll be working inside this folder as well. So
Can
yeah,
you please increase the font size, or we are not able to
yeah,
see? Oh, yes, sir. Yes, sir.
yeah, you can what you can do is that I've shared you the content, right? So like you can see it from there as well. I'll try to make it large for most of the time. For some time I need to just make it short to view more content. Like okay, so I'll try to keep it large mostly. Okay, so okay, thanks. So let's proceed. So like changing a directory, these are the functions. You can do
Hello,
this
sir.
using the, yeah, yes,
Uh, there is an option for Zoom in WebEx on the top. So if we want to increase the size, we can do it from our side also.
okay, okay, okay. Thank you for the clarification. Okay, yeah, I can see there is something.
The participant can also do that.
Okay, thank you for the clarification. So yeah, so let's proceed. So you can list the content, whatever the directory is there. So I can do that using this list dir command. Okay, so these contents are previously shared with you. Just you can just take a look there as well. So now let's get into the interesting part. Like if I want to, if you see there is no folder. Okay, so if I just so inside the sample data there is no folder. So if I press this, like if I code like this is the location, and I want to create a folder called eict. Okay, so if I have to like press, like I have to do this particular command, and if it is created, it will if there is no such folder, it will say that this particular folder is created. Otherwise it will say that it already exists. So let's try. If I run this, and if you content now, so if you see previously EICT folder was not there, but now this, if I do it again, it will say it already exists. So first time when I create a folder, let's delete this folder again just to clarify again. So if we see there is no such folder. Okay, so if I press this particular command and this folder is created. Okay, if I press this particular command again, so it will say that it is again created because of this part of the code. Like it just takes a if and else condition, and if it says that if the folder is created or not. So by this particular command you can create. So this is very interesting functionality. So you can do it using the collab notebook. So these are happening inside my Google Drive. If you are using your running it in your local system, it will be, you have to just like manipulate this content and sample data things according to like your directory name and those kind of things in your local machine, and the code will work properly. Okay. So if I want to share the content like list dir, like it shows the content inside this particular sample data folder, and if I want to see the content inside this eict folder, if you see the content is null because there is only this folder and there is no concept here, like no files are created inside folder. So if I say, if also there is another particular command so which prints all the content inside this like this folder, content folder, it will see that this is a directory inside this there is this particular .config file. Okay. So I believe this .config file was created, I previously trained some machine learning models previously, so that created this particular folder. Okay. And so these are also logs files, some logs files are there. Okay. So this sample data, as I was showing, these are the content of a sample data on the on like folder, and the like the folder, so there are multiple checkpoints and all those kind of things are there. So this prints whatever the content is inside uh, this thing. Okay. This sample this content folder, if I change this to content and inside the folder directory, this will also change. Only this will show the content inside this sample directory. So this is clear, isn't it? It's okay. So I built so yeah, so if I want to list all the directory here, that I can do it easily using this list directory command. Common commands that you should be aware of, like os.work, it like prints all the contents, and list directory as I previously mentioned, and make directory those as I previously mentioned as well. Yeah. So now if I ask you, can you create a text file using this thing? The answer is yes, you can create a text file. You just, so if you see inside this eict there is nothing. So if I run this, it creates a text file, and the content, if you see it, example.txt, and it contains this particular data. Like if I can also show the content here using this hello. This is a sample text file, very simple, whatever you can see. So I can manipulate it to hello participants. Come to day 4. We'll come to day 4 session 1. So I can modify it. The file is recreated and the content is this particular example.txt. Previously it was showing some other contents. Now it is showing some other content because I rewrote it. Okay. So like you can also rename this file, like this example.txt. I want to change it to new.txt if I say. So if you see, now it is example.txt. If I do it again, now it is new.txt. Okay. So you can like you can also say like know what is the stat of a particular file. So this file has 76 bytes and last modified at particular timestamp. As I previously mentioned, it is like shown by a particular this particular integer number. So it is a float number here because it is also considering milliseconds and those kind of details. But this is every unique seconds can be represented like this, and this is a permission. This is 644, which I'll be talking about in some time. Okay, so okay, I'll be talking about it very soon. So I can also delete the file as well. If I press this, if I run this, the file content is deleted. File is deleted. So new txt file, there is no file. It is gone. So I can also delete the directory as well. So if I see, the directory is again gone. So those kind of manipulation that easily can be done using this thing. So you can give access to a particular before I talk about access, like everything else is clear, like this creating directory, making file content and those kind of things. Is it clear? Can you confirm? Yeah, these are Linux commands. You are right, because
Yes,
in
sir.
underlying like they use those kind of things. So permission also, like there are if you see the permission in Python number. So there are particular like permission as well. So if you see this particular file, okay, so you can give permission to it like this. So 000 is no permission, and the permission varies from 0 to 7. Okay, so you will be giving read access, read and execute, read write access. So whatever you may decide, you can be, it can be presented in a binary form, like 0 0, like the right one is the execute. Okay, the middle one is the write, and this one, the left, most left one is the like read. So if you want to give someone the read and execute command, so read is one, execute is one, but the write is zero. So if we see like 101, it is a binary number. If you can like if you can convert it into a like decimal number, it is 5. Okay, so if you want to give someone read and write permission, it is 6. Just simple. Okay, so there are actually user. So yeah, so there are basically three groups here, like so there are three groups in Linux, like and also in Python as well. Like there is a owner, there is group member, and there is others. So you can give different permission for everyone. Okay, so octal is like the, so it can be presented like in a three digit number. So if you see that 0 is saying that I'll be presenting this number in an octal format. Okay, so if I say it the octal format, and I'll be, so I'll be presenting it into the octal format. Octal is another number system which contains number from 0 to 7, which is sufficient for this case. Okay, so that that is why it is presented in octal format. So for that, this first 0 and O is written. After that, you can give permission for 7. So find, so user or the owner has all the permission, group member has 4, which is only the read access, and the others have only read access. So 744. So 600 here is that read and execute. So 600 is a read and write access is there, and like read and write access is there, and uh, like and other have no access. So if I do like this, let's try it on an example. If we see that, let me again create the directory once again. Let's try and this thing once again. Just install directory. Let's, I will make the directory again, and I will create the file. If you see again, the directory is there and the file is created. Now I do not want to give any permission to anyone. Okay, so now if we see the like if I want to um, if where was it, if I want to read it, I can read like this is the content. Hello participant, welcome to day 4, because there is permission. Like initial permission was 600. Okay, so now I am revoking the read permission from the user as well. So I'm like revoking it. Oh sorry, this should be txt. So txt, no such. Okay, so I just made a mistake. Like the current working directory, I need to change it to this particular content. Okay, so I need to move. So now if I press it here, so now I am inside this EICT folder, and I can give this example. Just a minute. Okay, simple data and then EICT. Okay, so I need this. Now like you need to put that backslash as well to get in. So now I am inside this EICT folder. Okay, now I can like rewrite the access here. Where is the file? Example.readme. Example.text. Uh, uh, oh, sorry. This I am again getting out. Just a minute. Yeah, now I believe I can do the permission here. Yeah, I was able to successfully do it using this. I removed the read permission here. So previously I was. Now let's see if I can. Yes. So yeah, and yeah, it's working, but if I do it, but anyway, I can view it, but there should not be. There is some problem here. I don't know. Like I need to think. Like I need to redo. I believe I have is redo the permission, but I don't know why it is happening like this. But anyway, that is. But you can like change the permission for the user as well. So I think it is because I am the owner here. I believe I do not have the right to do anything to the owner. I believe so. So if I do this, yeah, okay. But anyway, the content is clear, like how you can manipulate like the permissions, you can those kind of things. Anyway, somehow there are some problems that I need to see. Okay, but now, but overall the concept should be clear, isn't it? Is it okay? Like, do you want to clarify anything? Okay, okay. Any more doubts? Like two more
So,
questions has
hello, sir.
yeah. Yes, yes.
Can you repeat the last concept of changing permission?
See, here in there are multiple groups. Okay, so there are three types of user. So one is the user itself. Okay, one is user. Let me write it somewhere. One is user or owner. Okay, so I am me. So I believe owner permission cannot be changed. Okay, then is group, and then is you and then is others. Okay, so if I write permission is 0 0 so and 777. So it is that everyone has every access. Everyone has every access. Okay. So seven. So if I write this like this, so it will say that everyone has every access. So it is for 777. So if I write it for 700, so this is the access of owner. It first it is like owner or user. Okay. Access of group. Access of others. Other. Okay. So it means the user has all access. Others none. So it means that if I share this link with you, so if I share it with a group of people, so group is that if I share it like this, uh, see if I share any particular email ID. So these are some of my friends. So if I share the access with them, so they will be a part of the group, and also I can copy the link and share it with everyone else. So those will be others like groups with the email IDs, and others are anyone with link. Okay, so I have some permission, the group has some other permission, and the like anyone with the link will have any other permission. Like they can also write on this if I give them permission. So if I rewrite the permission to 7 and 0, so people in this email IDs as well, this people within this, so whom I can share, so they can also like read, write, and execute this thing entirely. But if anyone with the link cannot do anything, so that for that I need to change it to some other number. So every number can present one particular. You see, this is the particular thing here. So permission table, like 000 is the no permission, 1 is the only execute permission, like this. So 777, like 111 is basically 7. So this is the binary representation and this is the octal or decimal representation. So both are same for this particular set of numbers here. So here it is presented by some particular number here. So this number is for every, like the permission, unique permission is for everyone else. So this 7 means that, so if you see this table, it is means that all access. So if I write it to like say 4, okay, 4 is only read access, nothing else. Okay, so clear. So I hope this is clear, right?
Yes, sir.
Okay, thanks. Okay, so these are the two modules. So two modules are clear. So let's move on to the third module. So the third module is, so let's write like this. So this is a special operator called walrus operator. So this is the next topic for today. So purpose is to assign a value to a particular variable. So I'll be like coding and see how it works. And the usage is that it is useful that if you want to assign value immediately to expression. So it is called walrus because so its shape is like a walrus. If you see, this is a walrus, is an animal, and like shape is like this, and it is like this. This is a colon and a equal to. So it resembles the face of a walrus, and that is why this interesting name came into the picture. It is a walrus operator. So now, if you see, it is very much similar to equal to operator, right? Equal to, like you assign some value, but walrus operator like allows that, what gives you some flexibility, like some more functionality over the equal to operation. So I will be discussing some of the examples. So if you see, so this should be inside the expression, and this is a very special thing that was introduced in 3.8. So this walrus operator is only available in 3.8 or newer versions of the Python.
Excuse me,
Okay.
sir.
Yeah.
Sir, I think your screen is frozen, sir.
Is it so? So is it so? Okay. Now can you see? Can you see the slides?
Slides, no, sir. We can see your current screen, sir.
My current screen is what, like this library, or this I'm currently okay.
No,
Just
sir.
I will
Slide is.
uh, just a minute. I will just stop sharing and reshare. I believe that will solve the problem. So can you see the PPT now?
Yes, sir.
Okay.
Yes, sir.
Okay. So this is a operator called walrus operator. Okay. So if you see, so this is how it looks. This is a colon and an equal to. The purpose of the operator is to assign a particular value to a variable. So the name is kind of very interesting, isn't it? Like a walrus operator. So if you see, this is a picture of a walrus. So his face and his two teeth is there, and it resembles like this. So that's how the programmers came up with this interesting name of walrus operator. So this is very much similar to the equal to operator. If you see, like it is like applicable to statement only, and this is applicable to statement as well as expression as well. Okay, so if you see that this was there since the beginning, and it this operator was introduced in Python 3.8. So these you can access this version, the walrus operator in Python version of 3.8 or newer version. Okay, so if you see that it returns no value equal to operation, and this returns a assigned value, which is true or false. Okay, so I'll be discussing them with an example as well. So if you see this particular example of, okay, I'll just close this runtime. Yeah. So this Walrus operator. So screen is visible, right? Hello.
Yes, sir.
Yes, sir. Yes.
Okay. So you
Yes,
can see the
sir.
screen. Okay. So I'll be discussing about the functionality of the Walrus operator. So so this is a very like naive example, but you can see the functionality of the operator here. Okay. So if you see, I define a particular method called difference. So if I put any two numbers, it will return the difference, the absolute value of it. So 2 or 2 doesn't really matter. It returns this one only. Okay. So if I run this operator, like if see run this, so it will print like this. Like it will printing that 1 is less than 4. Yeah, because it is saying that it is less than 4. If it is else, it is some more value. It is 30, 39. Say it will not print anything because there is nothing in the else part. Okay. So anyway, so when the value is less than 4, it prints like this. This is a very simple example. If I want to do it like this, like you can do that, like you can, like here if you see, I am calling the function 2 times. Okay, now calling it 2 times makes it's like 2 function time calls. Although this is a very simple function, whenever you design a very large program, functions are not so simple. So you need to optimize, like a good like program should be.
Sir, your screen is frozen, sir.
इससे ज्यादा विजय नहीं बोल पाएगा तुम।
तुमको सुनना है क्या कहो?
Yes, yes. What happened, beta?
What happened, Commode? Why are you using such vulgar type of language? Sorry, is disconnected.
Hello, am I audible? Hello.
Yes,
Yes,
sir,
sir.
audible.
Yes, sir.
Okay,
Audible,
okay,
sir.
okay. Miss, is my screen visible or do I need to? I
No,
think I
sir.
need to reshare.
No, sir.
No,
Screen
sir.
is
No,
not
sir.
visible, sir.
Your
No, sir.
screen is not visible.
Okay. Is visible now, right?
Yes, sir.
Okay. So can you view this?
Yes, sir.
Yes, sir.
Okay, so it's clear, like it's a newer version. Like, were you able to listen? Like, walrus operation, like this is. So this was clear, right? I covered this slide. A new one. Okay, so this is a walrus operator. So yeah, so this is a very newer version. So I'll be like, let's code and let's understand what this is. Okay. So if you see the difference, okay, so this is a very simple function. So it's clear, right? The screen is clear now. Everything's okay. Correct. Covered. Okay. Now, if you see, now if I want to like, if there are two difference function here, and I want to like reduce the complexity using one operation, right? So if you see, if you might think yourself like, why, what is the problem? It is running very quickly, but when you design a real life app, the like size of the functions are huge and it contains huge complexity. So like you have to optimize it properly, because in order to optimize, the latency will be less. Like no one will want a app which takes a lot of time to do anything, right? Because everyone thinks that I want a first internet, I need a first app, was whatever it is. So you can reduce that using this, like this. D is a value which is storing the difference, and it is comparing the difference is less than 4, and it is like this. Okay, now it's better, but the thing is there is also one part more integer, like I am referring here, d. You might also reduce that as well, like we can like replace it with this walrus operation, which will, which can directly call it here, like it is like this. Okay, so if I, instead of walrus operation, if I just press a equal to, it will print some kind of error. So I can do away with that with the walrus operator. So basically I am calling the function here. So this is a clever way of calling a function which is called inline functions. Okay, so these are special type of functions called inline functions. So if you see this another example, here the two values are passed, a and b. So every time the value of, like the difference of values is less than 4, it a keeps on adding 1. So initially 5 and 8 was there, so the value difference is less than 4, it add 1, so now it is 6. So if you see the difference, it is showing. Okay, the distance or difference you can write. Okay, it will be showing it like this as well, like it's in this walrus operator. Initially it 5 to, it went on to become 6, the difference was 1, then 7, the difference like, so 8, the difference is 0, like, and again 9, 10, 11, 12. Okay, now it's like this, 3 to like 5, 3, then 2, 1, 0, then 1, 2, 3. Okay, not 2. Okay, so it if you just increase it to 9 as well, so it will 3, just simple. Okay, so there are more ways you can do that using this walrus operator. Like you can also
Hello,
do
sir.
away with the yeah, hello.
Sir,
Yes.
what is the meaning of D colon equal to?
So this is a walrus operator. So this is assigning the value in this value d. Okay. So it is what previously, if you do not write d here, okay, you have to rewrite it in another line. Okay, you can simply do away with that with one line as well. Like if you do not write it like this, you can just simply do this. This is another way of writing it. This, like, it is more of an assignment operator. This is a little upgrade over the equal to operation. Okay, you can also do it like this as well, is another example. So clear, like why it the walrus operator, how it works, right? It is some addition to equal to. So that is why I showed like how it is different to equal to. It is very much similar to equal to, you are right, but yes, so this
Excuse me,
is
sir.
another functionality. Yes.
What is the meaning of F inside the print statement, sir?
Can you repeat this?
Oh,
Oh,
yeah.
F.
Yes, sir.
So F is stands for formatted string. Okay.
Pardon, sir. Can you come again? Formatting.
Yeah. Formatted string. So are you aware with the C++, right?
C little bit we know, sir.
Okay. So so let's just simply, if we remove the remove this F, it will simply print this. But if I press F here, it will like it will print the value of D variable. Like this will be dynamic. Okay. See,
Yes,
clear?
sir. Yes, sir. Got it, sir.
Okay. So yes, clear, right? One last operator is clear. So okay, let's move on. So these are the three topics. Now there is a big and very interesting topic called regular expression. So, Python has like gives you flexibility of this regular expression. Now, if I ask you like why do you need so, like this is a very interesting thing. Okay, so I will be doing it with this thing. Okay, so there is I have shared the content here, so I'll be closing this Walrus operation here. This runtime disconnect and delete runtime. Okay, now this yeah, this thing, and okay, now this regular expression. So this is a very interesting thing. Okay, so this is the most like interesting topic for today's lecture. So now if I ask you like this is used for pattern matching. Okay, so let's come up with directly with the use case here. Okay, so if you are given you this text, these are very random text generated, the numbers is obviously not true, some random number is put here. If I ask you like if you can parse the text, like it's a very big text, you may imagine, like if I ask you and say that like can you just like put all the information, like all the phone numbers in this text, like it contains this Elon Musk phone number is this thing, and Tesla CFO phone number is this. Hypothetically, obviously these are not his real number, real obviously, but let's for sake of simplicity, let's understand this. So if I ask you, so there is a very big text. This is a very small text. You see, and imagine there is a very big text, and if I ask you to list out all the numbers here, okay, so can you do that? The answer is yes. Like so, if I write it like this, like you can do that using this module, this regular expression module. So I'll be like talking about them, like how it works. So if you want to list one particular number, digit of a number can be represented by this. Okay, so if you see this is if I type this slash d, it like it will show all the numbers. So this is showing match 1, match 2, match 3, match 4, dot. These are all matches, right? But a phone number contain 10 digit, right? So this I have to write it at dot 10 times, right? So I can do it that, but there is a better way to do that. If I do it like this will list all the 10 this digit here. Okay, so if you see matching is coming like this. Okay, so this, if you can see this is a match. Okay, see if I press 5 here, yeah, 5 here. Okay, so it will be matching this only, like 5 consecutive digit. This match 1 is this thing, match 2 is this thing. 5 consecutive digit it is matching. If I write 1 here, it will be matching 1 this kind of thing. So if I do 10 here, and there is 10 digits are matched. So if this is an example how you can match all the digit. So if you see like this is, you can represent your number like this, right? But in like you can also represent your number like this. So in, so this is a code for America. but for India, I believe there should be 9-1 something something something, right? So you can also do that like this as well. So for that, what you need to do is that you need to, if you see that there is a group of 3, isn't it? There is a group of 3 here. Should be inside a bracket. So bracket, you need to present it like this colon, this slash and bracket. Not simply bracket will not work. So like this. So if you see, this only matches with this thing. So after that, I need to match it with this thing. After that, there should be 3 more digits. After that, there should be 4 more digits, right? Like this. So it matches with this particular number. But I lost the access to the previous number. So that is why you can write it like this. And it says that either I will search for this or I will be searching for this. So if you see, both the contents are matched. So this is the entire text. There are 2 phone numbers and both the contents are matched. How I'll get into how it is related with Python, but this is called regular expression and this is used for pattern matching. So this is how you can, from a particular very big, was it
Hello?
clear? Yes.
Yeah, your screen is not visible. Kindly share it again.
I believe it is visible.
No, no, it's not. Some of the participants are querying also.
Okay. Okay. Is it visible now?
Yes, now visible.
If my screen has frozen, can you just like turn on your mic and say from the next time? It's very difficult to like see the chat as well while discussing. Okay. So this is a special like a regular expression. So in this text, this is a sample text given. This could be anything else also. Okay. So I want to like list all the phone numbers here. Okay. So here this is a website. You can just simply, I'm sharing it in the chat. Just open the website as well. So the web, so you can just write some random text, and if you want to like read all the phone numbers here, right? So so this symbol, this /d symbol, is used to find all particular. Okay, so phone number contain 10 digits, right? Because there is some number here, so it's not valid. So phone number contain 10 digits here. So it will say that it is matching with this and this. Okay, and but now if I want to, like, this is also a phone number here, isn't it? Okay, and this is a phone number here as well. So it is not catching. So I want to pattern match like this. So it starts with a equal to and followed by 3 digits, right? Then followed by a this thing, uh, dash, and followed by 3 digit, then again colon and this dash, and then followed by again 4 digit, right? So this, if you see, this should be matching with this number, but it is not, because for in bracket also you need this to see that this particular number is matching, or the number can be represented like this as well, like all like 10 digits as well. So if you see these both the things are matching, but like exactly if I want exactly like this, okay, so it should be like like this like second
Hello, sir.
yeah,
What is the meaning of slash in the pattern?
the slash is this is a special symbol, right? So you need slash for that, okay. So like otherwise equal to doesn't make any sense, because these are special symbols. So is anyone like familiar with latex here, which is used to write research paper? So here also like these special characters are like generally represented with a slash character, like slash, like this, okay. So it's like that, like special character called slash, like this bracket should be presented like this. So this is the syntax. There is no particular rule about this. The designer designed it like this. So if you do like this, if you can just see the content here, okay. Like these list all the two phone numbers here, okay. So I will just simply run the code here. So this is it. So this is the module. Just let me run the code here. So it prints both the phone numbers, right? But you can also like there is find all and there is search. So this is a syntax. So you have to learn the syntax. You can't do anything about it. So this is the thing that I calculated using this, right? Like that you should know like what do you want to have. And find all basically it like list all of them. And there is another called search as well, which will represent it like this, which will say that a match found, the span is between this to this. But here it will not say everything. It will say if there is one, it will say, otherwise it will not do anything. Simple. Okay, so this is the syntax. You should be familiar with the syntax. So yeah, this is like this. So it lists both the phone numbers here. So here you can also do here these things too, like replace particular thing. This slash is for space. Okay, so white character represented at slash s. So the rain in Spain. These are very simple. Uh, so now if I want to like every of it, like every word is generally separated by a space. So if I want to split it using space, so I will be coding like this. And this is a particular text and it will print all the words. See, if I want to split it using this I, so if you see there is particular I command. So let's see what it comes. This thing will come, then there is I, then this thing will come like this. Uh, this thing will come like this. Sorry, A and I, and in last there is n. So there is, you can this basically split it using some command as well. Or if you want to do it by space, simply do it by like this. If you want to replace a particular digit, like if you want to replace space by some number like this, it is a syntax for doing that. So initially the text is like this, the replace text should be like this, simple. If you want to replace it with some other number o, it should be like this. Anything you want, say if you dollar you want, you can do it by dollar as well. That's all. Okay, this is the phone number matching is there. So there is some more example. I might not be able to cover all of them, I believe, because of the time problem. But I believe you can. So the agenda, like the here they want to find out this. There are note and note 1 and note 2, okay. And what they want to do is that you want to print this overview and the summary, like the title of note 1 and note 2. So how to do that? Like if you do that using the text, like let's copy it there. The text should be here and I want to copy it here, right? So if I copy the content here, like, okay, so I want to, how note is written, if you see, note is like this, note 1. So note, if you write, so it will list all the notes. So there are one note from 0 to 4, and there is one note from here. So these are the characters, like what are the characters here, like the range of the character. This is from the 0th location to 0, 1, 2, 3. So before the 4 location it ends. So so this is like this. So this is note 2. If you see deep into the text, there is another note written here. See, it is another note which is written here. Its location, it is pointing like this, 1389 to 1393. So if you write it like this, so note, if you see, after that there is a space, and after that there is any number. So it will say that there is note 1 and note 2. Now after number there is another space, and there is one colon like this. And after that if you see, after that there is this title. So I need to extract the title only. So I need to do that using this this caret sign. So it will say that till I, like, it will stop if I don't find this if I do not find this new line character. This slash n stands for new line character. I can easily do that using like this. So it will keep on repeating. So now if I star, if you see, there is two special notation. One is called star, one is called uh, plus. Star happen for 1, 0 or more times repetition, and plus happens for one or more times repetition. So if you see this particular example, so it is repeated, like, so I will be searching that stop. I will be, if I write this,
Sir, your screen is not clearly visible.
why, like, is it, can you okay, what you can do is that can you
It
go
is
to this particular is it because of the font size, or
no, sir. It is blur. Now it is clear. Hmm.
okay, okay, see, if you write it like this, okay, so it say, so
Yeah,
it
all
says that
participants are requested to please mute your mics. Okay. Thank you. Over to you.
uh, okay, so it says that like stop until you find a new line character. But you might not know, like, like what could be the overview and this summary thing. Okay, the size could be anything, right? But like you can do that using this star symbol. The star symbol say that the repetition should be 0 or more times. There is another symbol called plus symbol. If you write it like this, so plus symbol will also work here, and plus symbol will say that repeat it till 1 or more times. Simple. Okay, so this is just stands for repetition. Now if you see that there is note 1 and note 2 is also coming into the picture, you just simply you can replace it with this thing, this bracket you can write. So bracket, it will just simply, it will say that uh, this overview. See, it say that group 1, this is saying the overview, and this is saying the overview. Like the output will just be this, the content of it. Okay, this is a very interesting thing. I believe it's like you need to play around with it before to understand. Like it's a very interesting. I have shared with this website link with you. You just put some random thing and you can play around with it. Okay, so here they have also given the like explanation as well, like why it is happening. So if you do something very random and you might not able to find, and you can easily just read the content, and you will know like how it works. Okay, it's a very good, interesting thing. And also they have these things for references as well. Okay, so if you see, there is like general tokens, what are the general new line token, okay, null characters, those kind of things, all tokens, like anything you want, you can find it here. Like repetition of 2-3 times or more times, like the previous example I say, like 10, like 3, this 10 digit repetition. So I how was like this. So those kind of things should be here. So yeah, you just, if you do it like this, you will find this. So these are some more examples of finding which financial year you want to find. Okay, so you just, there is not much time, so I will request you to, like, I have shared the notebook with you, you can just play with them and you can find them. It's a very interesting module, this regular expression, but yeah, I believe the time is very less to understand this, so you can just play around and you can learn by yourself this. So the basics I have covered, but there are more into it. Okay, so yes, so there are topic for today, and there are 2 more topics. So uh, next one is this thing, time based, this. So here that I'll be the sample program. This will not, this is a way that I have written, will just instruct, it will wait for some time and it will keep on the messaging. So if I run it, so if I run this code, so it will print like time to drink water at a time. So this is the Greenwich. So it is like this will repeat on the message for every 5 seconds like this. So you can see the timestamp here. Okay, so this is the message that you can write, time to drink water, whatever a bit. So this is a very random message that I took. Okay, so there is nothing to do with water. So this is how it works. So this is this, you are calling this reminder function here. Okay, so the reminder, the code is very much like I have inserted command line here, so that it is easy for study it. So now that I am starting a loop here. So loop contains for 1 to number of reminder time. So I inserted the, like the reminder is 5, like reminder interval is 5, so it should be 5 second. So every 5 second it will do reminder, and the total number of 8 happen. So the loop will run for exactly 8 times, 1 2 3 4 5 6 7 8. So if you see, the loop has run for exactly 8 times, and if every 8 time it will print this particular message. So if you see, the every time it will call this particular function. So it's, so the main function called the start reminder function, the start reminder will print this thing, and for every 8, like every time it will call this remind water function. So function will basically wait, like print this particular message, like time to drink water, like what is the current time and what is the time to drink water. And after the reminder function is called, it will sleep for duration, like this 5 second duration. Okay, so as I've written this 5 second duration, and it will keep on going on like this. So this will, loop will happen for 8 times, and after that this particular line will be printed. All reminders for today are done. Stay hydrated. Okay, this is a very simple program. So is this clear? So I shared you the content, you can just copy the code and you can. Yes,
This Plier is a library.
huh?
Plier
Can you
library.
can you repeat? Your voice is breaking.
Plyer. Plier. Plyer. Plier.
I'm not sure.
I'm not sure. You are importing notification function.
Where in this?
Fourth line.
Uh, oh yes, from Plier. Plier is another package, not a library. Yeah, package you can say. Import notification. This notification comes, like if you want to print message like this. you can import this spline library, but you can ignore it for this moment. Like you can simply write a print message here. So this is I like, so that's not necessary at this moment. Okay, so actually in Python it is open source, so there are multiple libraries, and like it goes on increasing day by day. Okay, so it's not like possible for anyone to know all the libraries. So I like suggest to know the basic libraries. Basic libraries is this time module, OS module. This previously I've studied about NumPy, pandas. Okay, if you are working with graphs, there is matplotlib library. Those kind of things. Okay, clear? Is it okay?
Okay, sir. Okay.
Okay, sure.
Hello. Am I
Yes.
audible, sir? Sir,
Yeah,
like
yeah.
you told us, that there are thousands of libraries. So can you give a name of, say, top 10 or 15 what we should remember? At least
If
you can.
there are like this NumPy, pandas. Okay, there is matplotlib. Okay, then so,
like approximately how much we should remember? 10, 20 libraries by which most of the work can be done.
see, 3-4 libraries are enough, I believe. Okay,
Just
so
can you
NumPy,
put that
panda.
name in chat box if you can do?
Yeah, I will. This is NumPy is very important. Panda. These are two main libraries. If you know everything, okay, so you can know. So like these added flexibility. Uh, can anyone turn off your mic? It's disturbing. Okay, so these are for like numerical operations. So without these also, you can write code as well, but this will make your work easier. There is, if you are working with graphs, matplotlib is there. Okay, so those kind of things are there, and so now like regular expression which I taught in the last just few minutes ago, that is also very important, I believe, like pattern matching, those kind of things. So basically, see, Python is such a programming language. It is used to train AI models. It is used to write code for like this rocket launching as well, right? So the scope is vast, right? So like it's not possible for anyone to know about all the libraries. So if you should be working in a particular use case. So gradually, whatever you will, if you feel that you need to learn about anything, you learn that automatically. If you know the basics, learning a library is like it will take you about 1 day only. Okay, because the basics should be clear. That's all. The libraries are basically syntax, some scripts you use. If so, for example, okay, if I do not use this RE library, regular expression library, can't I do this? Answer is yes, you can do this, but you need to write a huge amount of code for it. Okay, but if we know this library, your work is reduced. The point is this. Okay, is it okay?
This this RE library you talked about. Huh? So this library may be having how many lines of coding? Like approximately.
I don't need to, you need to go to the source code and see. Like I am not aware of this, but yeah, it should have a quite a huge lines of code. So if you have done C++,
Uh-huh.
have you done C++?
Yes, sir. Yes, I have done C++ during my academic, and I liked it very much.
Yeah. So like in C++,
uh-huh.
in C++, if you want to do the exact same code, you might have to write around 20 lines, right? But lines of code has nothing to do with complexity. I agree, but yeah, it reduces your workload. That you should know.
And one more question I have, sir. Like I had learned C++. It was very interesting.
Yes.
If you remove this library part from Python, so if you want to compare Python with C++, removing that library, so are both same, or Python is still more feasible than C++?
Your question, there is some like things. Okay, so if you think of a library, if you think of a programming language, to how simple it is to learn, Python is the best. Okay, but the more the simplicity is there, the complexity, underlying complexity is higher. In C or C++, if you know how to deal with pointers, those kind of things, those kind of flexibility is not there in Python. So making this Python, like if you run the same code in C++ and a Python library will take much more time, because it is dealing with like more internal complexity behind the scene. You see, in the yesterday's class I talk about abstraction. Like, I am writing a code in Python, I do not need to know about what is inside the Python, but it must be executed, right? The execution is happening in C++. Since it is much easier library, so it's very much faster. So if you want to design a very low latency software, C++ is a very good option. Python is never a good option for that particular case.
So for
Python
what?
has some,
For what you told?
see, it depends on your use case. Okay, if you want to design a very low latency software, okay, so you want to design a broker like stock market broker who will be like dealing with orders in seconds. So latency is very important there. In also banking application, right? Python is not an option for those kind of things. Like, Python is never used. So in C++ is very much appreciated in those kind of, in those fields, or any other languages. The more the basic, the complexity is less, and it is more faster. The lines of code, the programmer like job increases. Like, you need to, for this only, I write 3 lines of code here, but for C++ I need to write 20 lines of code, but C++ is much faster. You have to consider that also. Okay.
Yes, it was very
So,
interesting.
so it depends on your use case. So Python is mostly popular. If you see, Python came around in 1970s, 80s. If I am very much like, or maybe around this, those kind of this. Before 1990, it came total. Okay, but it became popular after 2010 because of the libraries. So after 2010, this machine learning revolution happened. Like, people training AI models. So to train AI models, if you code in C++, it takes a lot of time, and it's a lot of complexity also is there. So libraries came in, and people say, okay, let's learn about Python. Well, Python became very popular because it's very easy, right? And also in like training models, you do not need to, like, you don't need how much faster your code is, but how much efficient your code is. Like, testing, like, training is, latency is not a problem in training model, but testing models, it is a problem, like when you deploy it. So that is, I'm not getting into the details of it, but Python became popular after 2010. The main reason is the simplicity, okay, and the fast use case of it. Like, the libraries are the main things for the Python. Is it okay? My explanation is satisfactory?
Yes, sir. Yes, sir. One more thing.
I would like to add one more thing. As you asked for a huge library, I was taking Python 2 years ago. C library is very huge. Even in 2 years there can be changes, but C library is huge than Python library.
Yeah,
Python
yes, it is
Python
used. Some
library,
functionalities are used. You are right.
yeah,
Okay, but
Python
yeah.
Python library is more towards machine learning and deep learning. But why Python is popular? Because Python can import modules and library of C or C++. Python is compatible with these languages. So Python is using its own library, plus it is using the
Yeah,
library of C and C++ as well. And vice
but
versa.
yeah, there
Please.
are some libraries that might use, but most of the cases it has like its own libraries. Okay, so, but yeah, underlying, if you go like the Python, if you see the system level, the complexity is higher. The more higher you need to deal the problem in different way, that like increases the complexity of it. So runtime case, if you run a particular program and the same program in C++, C++ is faster. Okay. So that's the conclusion that you can conclude from this. Okay. So yeah, anything else?
Sir, one more thing, like in C++, we used to denote the type of like if X is integer or variable or float, we used to at the top we used to describe it. Does it happen in Python also? We have to describe, or we have to write directly without describing?
Can you repeat? Your voice was
Like
very much.
sir, if I want to add two numbers, okay, so X plus 5, so I have to define X is variable or string or integer. In C++, we need to define that X, whether it is
Yeah.
integer or variable. Does it happen
I
in Python?
understand. You can define, okay, int a is equal to 5, you can write, Okay, but a is equal to 5 will also do. But if you write, yeah, that's a very interesting point actually. If you write a is equal to 4, okay, and if you write, screen is visible, right?
Yes.
So it will work. Believe what I have done. This, so it works. I probably some problem is there. I think it works in some other version. Maybe some version problem is there. Yeah, you are right. It works, but you are so okay. I think you need to import this numpy for that. But yeah, it works basically. So some library problem is there. Works if you are defining it as a number, so it actually makes your execution faster. It is saying that it is an integer, but if you are not saying that it is not specified, it takes more time because it need to verify that it is a number here. If you do it like this, it takes it as a float. Okay, so if you do it like this, it takes it as a string. Okay, so
Python is not necessarily mentioned to define it, isn't it?
hello, am I audible?
Yeah, you're audible.
Okay. To see this, if you see, this is a very interesting output that I am facing. Can you like say why it is happening?
Your screen is not visible. Suwati, can you hear me?
Yeah.
Yeah, your screen is not visible.
Okay. So hello, is my screen visible now?
Yeah, it's visible. Thank you.
See, if you write your code like this, okay, say a is equal to int 4, you it works, right? Okay, so here you are saying that it is integer, okay, but you when you write it like this, like you are not specifying it's a integer, but it understands it is a integer, and but that understanding takes some time. Okay, you can also do it as a string as well. If you do it like this, it will in like consider it as string, and it will just concatenate both of them, 4 and 5. It will concatenate and it will give a plus b. This is basically concatenation. Okay, if you do it like this, it is saying that integer. Okay, it is clear.
Yes, sir. No, it means it's in Python it's not necessary to mention the type of data, isn't it?
Okay, it's clear, right? So I have one small topic left for last topic, which I just get into the brief of it. You can uh, this is called discrete event simulation. Okay, so if you see, this topic is like you are simulating multiple events together. Yeah, so if we see, so as we're talking about, there is another library called random. Okay, random. So I am just randomly generating something. So that's why you are writing a random here. So there is heap queue. This is another library which is called this, which is the priority queue heap. Okay, and this matplotlib library is used for plotting the graphs. Okay, see, three libraries are imported here. So if you see the example, just I am basically, it's a very okay. I think I have this content here. So here I am just simply doing it like discrete event simulation. Okay, so imagine that you are simulating a single server queue, like a clinic or a toll booth or a coffee shop. Like people come and get their service done and then leave. Okay, so can you do that using a coding? The answer is yes. Like you need to understand like how long a customer are waiting, how much like customer can we serve, and what is the arrival rate and the service rate. Okay, so if you see like if you are in this example, you are simulating like 100 minutes, and every customer like on an average customer arrives every 5 minutes, and the service takes on an average around 4 minutes. So it is a event based like simulation, like arrival and departure is there, and depending on the service time the departure time is decided. So those are like this, we just print the content here. Like if you see the content like this, so it is a queue, right? So it is simulation time. The arrival time is say every 3 minutes people are arriving, and every on an average. So this is might not be 0, 3, 6, so on, 0, 3, 5, 7, 10, whatever it can be. The average arrival rate is one arrival every 3 minutes. So people are coming in and they are getting served on an average around 10 minutes. Okay. So this is the event that I am managing. Like so, I am doing the simulation, and this is a code like an event arrives, and will like add it into the queue. So priority queue is a kind of special kind of queue which will just store like how many people have arrived, how many people are waiting in the line. So and the top one like people will get their service done and they will leave. So if you do this, so if I have just simulated right, so if let it run, you can see the results, and that could be like this. It will clear your doubt. So if you see at this millisecond, one arrival happen, the queue size is 0. Okay, so it another arrival happen here, then another arrival happen here. So so people are coming in, and at this time, two people leave simultaneously. Okay, third people coming in, so people coming and they leave. So if you see that people are coming in here, here, as you see the queue size is increasing. Like people are waiting in the line. Okay, and these are happening like people are waiting in the line and so here I just plot a graph like what is the waiting time, every departure time to waiting time. So at every time instead how many number of people are waiting into the queue. So it's so this is done by this. So total number of customers served like it's okay, 6 customers were served, like 6 departure were there, like 6 departure was here, and every average waiting time was around this 32 millisecond, right? Like this. So if you see, if I manipulate, like if I like change the arrival rate is every 5 minutes and service rate is all 4 minutes. If you see the graph changes and the waiting time reduces significantly because the average waiting time is less, right? So queue size, if you see the in previous case, queue size was very high, but now it is not crossing 1 or 2 because of the values here. So here in like you can simulate, although it's a real life event which are happening parallelly, but you can like simulate the code which is executing serially. Okay, so this is one like interesting concept like district event simulation. Okay, so now that you can also like so this part is clear, the basic is clear. I'm not talking about queuing theory or Monte Carlo simulation, a very basic thing at that doing. Yeah, you can write about do about Monte Carlo simulation Python as well, but this lecture is not concerned with that. Like this session is a very simple thing that I am discussing. Okay. So yeah, so if you see, this is the, if you are just in the queue, just you are, there are very scheduling policies in like computer, that like there are many scheduling policies. Many people are coming in, but you can choose that which people you want to serve the people by the order which, this is first come first serve. Okay, FCFS stands for first come first serve. Then this SJF is the shortest job first. Like the shortest job is served like this. Like people, if you see, they're in the queue, but some people has a job of 10 minutes, some have about 2 minutes. So it's better that I free up the 2 minute people, and the largest job people should wait, so that the total waiting time of all the customers are less. So if you see, the average waiting time is generally lower in this particular case compared to the previous case. See, if you do this particular example, the arrival rate was 5 and the service rate was 4. The uh, this average waiting time is this, but if you see the change, like, yeah, this particular example, this value changes. See, average waiting time decreases, like this. So it depends on whatever you are using as a policy. So these are multiple policies. So there is priority. So if you are giving priority to each of the customers, so there is premium customer, there is not so premium customer. So that also you can assign different priority, and how the average waiting time changes. Okay, and this is a round robin fashion. So like round robin fashion is like this. Like people are coming in, and instead of doing every 2 seconds, you are doing job for every one. Like there are 5 people waiting. First 2 seconds you do job for first one people. Second, next 2 seconds for another people.
Hello. Suvarti, you're not audible. इसको फोन कर वो हेलो हेलो am I audible?
Audible, ma'am.
Okay,
But
okay.
speaker is
So
not.
there is
Yes,
there
ma'am,
is
you are audible. Audible.
so there is some audio issues at the speakers and we are resolving it. Thank you. We request the participants to please hold
You are
on.
not visible, ma'am.
No, I'm not visible because I have not turned my video on. Okay, which is not required. So, dear participants, please wait until the expert he's shifting some network. So there is some audio issue. So we request all the participants to hold on. Thank you.
Yes, am I audible?
Yeah, now you are audible.
Okay.
So we
Okay.
request you to please turn off your video so that
Hmm.
all the bandwidth is utilized in audio and live
Okay.
slide streaming.
So there are different kind of scheduling methods. Okay, I have coded for them. The code is well, like these are random people coming into the queue, and the queue is like their request is served. Okay, there are 4 types of requests: the FCFS, this first come first serve, this shortest of first. Okay, then there is this priority. Like every customer is given a priority, and then there is this round robin this scheduling where like people comes in and like wait for like their some of their job is done and the cycle is repeated. So the code is like well commented. You can see the code and you can understand like it's a very simple code. Okay, so there are multiple things. So I have used this matplotlib library to draw the graphs. Okay, so this is not much time to discuss the details of it, but yeah, if you have any general doubts, you may ask. Anyone?
Sir, your screen is not visible.
So I shared the code with you, right?
Yes, sir.
Yeah. So you can just so there's a four kind of pieces that I have coded and I have sent it. Run it in your own system. Is if you can understand it because I've like but I have commented properly. So I believe that you okay. So like time just excuse me, anyone? Go on. So we have
Your screen is not visible, sir. You are audible, but screen is not visible.
So dear participants, if you have any queries in the session, please let us know. You can unmute yourself or you can let us know in the chat box section. Thank you. Yeah, hello. The expert is joining. So one last code is remaining. So we will have a small discussion on that. And then we will wrap up the session. Okay, Sahul sir's session will start from 12:05. So we request all the participants to please be online. Suvarti sir is joining soon. So once he joins, he will explain the last code. Yeah. Thank you. Yeah, hello.
Yes, yes.
Yeah.
So you can so simple. So this tree-driven simulation file. Okay, this. So share the content with you. I'm just with the. If any doubts you may ask, I will try. Hello. Anyone? I'm audible, right?
Yeah, absolutely audible.
Okay. Doubts you may ask.
So, dear
I believe
participants, you can ask the doubts, if any. Okay, you can let us know in the chat box section, or else you can unmute yourself.
okay. So
Is there any reference materials or books we can refer? Because with the short duration, we cannot able to learn everything from the session.
I have in the I've shared some with you. Okay. So you can I've shared like ask me my personal certain webs or geeks. Okay. So you can
If you get the
follow
PPTs and the codes are already uploaded in day 4 of the drive.
pretty different section. There are some webs which I have referred during. You might want to refer that as well. The content like kind of things. Okay. Is it okay?
Okay, sir.
Okay. So, any more queries?
So I guess there are no queries from the participants. So in that case, we can wrap up this session. So on behalf of Professor Gaurav Trivedi, sir, the Principal Investigator of PNICT Academy, and Dr. Aryavrata Sahu, sir, who is the global coordinator for this program, I thank you, Suvarti, for coming on this platform and joining our participants and sharing your knowledge with all of us. Thank you.
Thank you all for your time. Okay, I'll be leaving the meeting.
Okay, thank you.
Bye.
Dear participants, with this we come to an end of session 1 of day 4 of this program. The second session will start shortly from 12:05 onwards. So we request all the participants to please be online and have a break of 3 minutes. Please remain connected. Please make your system remain connected, freshen up, and then come back by 12:05. We will have a 3-minute short break. Thank you.
Hello?
Yeah, hello.
Yeah, I'm available now.
Okay, sir. So shall we start then?
Yeah, we can start.
Thank you, sir. So,
Yeah.
dear participants, we are over to start with the session 2 of day 4 of this program. So, before we start with the session, we will have a short introduction of our next speaker, Dr. Aryavrita Sahu, sir. Dr. Aryavrita Sahu, sir, is currently working as an associate professor in the Department of Computer Science and Engineering at Indian Institute of Technology, Guwahati. He has completed his PhD from Indian Institute of Technology, Delhi, and his research areas mainly include multi-core, architecture, scheduling and programming, and computational social systems. He has more than 14 publications in reputed journals and over 36 conference papers. So with this short introduction, I welcome you, sir, on this platform to kindly guide our participants. Over to you, sir.
Thank you for nice introduction. So let's start. Whether you are able to see my screen?
Yes, sir, we are able to see your screen, sir. It's absolutely clear. Thank you.
Okay. I've already shared this. Okay, so let's start with the answer sessions. So today we will mostly cover the part Python multi-threading and multiprocessing. And in the current day scenario, without multi-threading and multiprocessing, nothing is possible. So most of the times we require these things. And almost all the simulator whenever design, all the system whenever design, everywhere we need to use this two concepts, multi-threading and multiprocessing. Okay, so no other options. So what is the difference between in this class or so what we'll discuss is what is the difference between thread and process. And whenever doing any multiprocessor programming and multiprocessor things, there are four things that are utmost important. There is lock, consistency, coherence, and interference. Then we'll go about Python multithreadings, particularly for I-bound process. And for CPU bound process, we have multiprocessing. So what is CPU bound? So wherever this process takes huge amount of CPU. I bound means the process take less amount of CPU but more IO. So it do a lot of actually disk IO or network IO or other kind of IOs. Okay, and we have a lot of examples. And towards end we'll see if time permit, then we'll go for a Python code debug and profiling, particularly threaded code. Okay, so before starting, so what is concurrent programming? Concurrent programming to simulate concurrent behavior of the systems. Whether we have a single processor or multiprocessor, sometimes we may require to simulate the concurrent because most of the environment is concurrent. Most of the means system is discrete event system. We need to model the actually concurrent systems. Okay, and multi-threading helps us to design the concurrent system. That means doing many tasks simultaneously, even if underlying processor is unique. Platform of concurrent programming can be uniprocessor, maybe shared or distributed memory multiprocessors. Again, and programming, parallel programming, enhancing performance of application by running. Programming parallel in multiprocessor. Running program in parallel. So if you want to increase performance, then that is the best way to do. Okay. So increase the performance of application by running program in parallel. Okay. So concurrent programming is meant to do both the things. It will simulate the concurrent behavioral systems. Whether running in parallel or not, that is different issue. Without running that also, you should be able to do. What is concurrency? Time and space. If you look at it, suppose there are only one CPU and you are running 4 threads or 4 work simultaneously, and in time slotted manners, round robin fashions. So every what I can say thread or work will get some unit of time, CPU time, and it get executed continuous. Kind of things who are simulating the concurrent behavior of the system on a single core. This is first one, top one. And bottom one is suppose you have multi-core. There are 2 cores. Then you can run the concurrent behavior on multi-core system. So concurrent programming, it may not mean for multi-core, it may mean for single core. That means we are trying to simulate or emulate the concurrent behavior of the real time or real phenomena, real world phenomena. That's why we require concurrency. What is the difference between process and threads? A process is sequential computations within own thread of control, and can be many threads in a process. Inside a process, there can be many threads. And what is a thread? Thread is a sequential computations. Is a sequence of program points that are reached as a control flow through source threads, and within a process there may be many threads. Okay, lightweight process. You can say it is a lightweight process, but many things, all threads get shared by the parent process. Many things are shared by the parent process, and within a process there may be many threads, and they share most of the address space, memory, and many things. Even multi-process programming also you can. So there can be multiple processes running, but they don't share many things. Communications, exchange of data between thread and process, either by explicitly message passings or through the value of shared variables. Okay, so either way. So in particularly tradings, they exchange message by thread share variables. Between process, it is message passing in must. Particularly MPI message passing interface is a very nice interface for doing very good communications and coordinated things. But it may not be for Pythons. Okay. Between threads, through the value of shared variable. Through shared variables also you can pass the messages. Okay, communicate among threads. Another important thing is synchronizations. So how to synchronize, because whenever multiple worker or multiple threads are working, synchronization is very important. Whenever you are making a group of people to work, then they should synchronize at different points, and they should do the work very nicely, collaboratively. Okay, so what is the synchronization point? If P is a point in the thread of a process P, and Q is another point in process Q, in the timeline, then synchronization can be used to constrain the order of in which P will reach to P or Q will reach to smaller. So we can actually order the things. That is, whenever you are doing bigger set of people working, and then you instruct the people, you go in this way, before he reaches, you should go and reach earlier. Kind of thing. Suppose a director is going to one places and his PA and all the things should reach a little bit earlier to that. Okay, so in that way, and they should do some kind of changes there and do. So this is kind of examples. And whenever multiple people involved, multiple party involved in a collaborative work, synchronization is must. Okay, exchange of control information between process. Already we have discussed what is time shared system and multi-programming. Time shared programs appear to run in parallel. So we'll come back to actual example with Python. I will run the code. I'll have a lot of source code available with me, and I'll show the things in front of you. Okay, so how the in Python it happens. So time shared systems appear to run in parallel. Particularly, suppose you want to achieve concurrency. You have universal system in your machines. Even if it run on a universal system. If you go back to Pentium PC times, so they use round robin threading. So every process will get some time share. Earlier today we used to have a universal system, and having universal system, and we used to listen songs, browsing, doing coding, and many things together. Okay, so that's is time shared system. And time shared systems, it generally it uses a concept of interrupt or hardware, allow the activity of a central CPU to be synchronized with the data channels. Okay, so if you look at, there are many implicit synchronizations also there, so no need to specify. Suppose process network in Unix. So in Linux or Unix system, the pipe, one process send data to another process send data to another process, and they process the data one after another. Suppose the example, we see number speed, ls wc minus l. So ls, the output of ls is redirected to wc minus l. Okay, so ps minus a grab modular. So ps minus a gives the list of process running in the system. Grab modular, from the list, grab the how many or what type of modular process is running. Okay, so this is the implicit synchronization pipes. And what we can see is concurrency as interleaving. So concurrent computation can be described in terms of events, where the events are an uninterruptible actions. How the internally means we can simulate concurrency on a universal system. Can you describe? Yes, can be described in terms of events, where an event is an uninterruptible actions. An event is execution of assignment, call, expressions, or anything. Okay. So Python threading, by default, it internally it uses bytecode or some interpreter, a serial interpreter, and on top of that, it uses a particular interleaver, interlocker or interleaver, we can say. Okay, global interlocker, GILUCs or GLUCs. Okay, and that make it concurrent. Okay, this is concurrency as interleaving. Suppose there are an interleaving is two process S and T. Suppose S is ABCD and T is 1, 2, 3, 4, and you can be 1 ABCD 2, 3, 4 E 5 who are interleaving two process at some points. So for achieving both the process who are running concurrently, or both the S and T you are using, both the sequence you are running concurrently, subjected to some constants. So we can mention that if required. Okay. So concurrency and time space already we have discussed. Suppose you have only one process, then you can achieve concurrency by time sharing, time division multiplication. At different time, different process will come, a different thread. And if we have multi-core, multiple CPUs, then we can use both time sharing and also space sharing. Okay, space multiplexing, time multiplexing and space multiplexing. You can see. Okay, time multiplexing, time division multiplexing, and space division multiplexings. In this case, if you look at two threads are running in CPU1, another two threads running in CPU2. T2 and T4 running on CPU2, and T1 and T3 running on CPU1. And in a CPU1, so T1, T2 alternately be there running. For some time T1 running, then after T3, then again T1, then again T3, alternatively they are running. So we are achieving concurrency in both multi-core, also in single core, using time and space division multiplexing. And we look at what are the basic coordinations, what are the synchronizations. So one thing is sharing. So sharing of data is particularly, so two threads sharing a common data X, suppose X, and if it is reading, no issues. If one is reading and other is writing, then that will be, because X is common for both the threads, and one is reading and other is writing, then that is issue. If it is one reading, no issues, one writing, no issues, multiple reading, no issues, because all is only readable. But any one of, there are multiples and one is read, one is write, and others are, what you can say, read. So one read, one write, that will be issues. More than one process, one must be writer. Then sharing need to be done in a synchronized way. That is, it need to be mutually exclusive. Writing up to a share object need to be in a mutually exclusive way. We need to use critical section. Another thing is barrier and fence. Barrier and fence, that means for all n threads, do the work and wait, everyone should finish. That means in general, what happens in most of the threaded program or threaded places, suppose in real life example, suppose 10 people are going from one place to another. So what you say, we'll go up to this place and we'll sing and we'll meet that point and we'll take breakfast. And after traveling another set of kilometers, you say we'll again travel up to this much and we'll meet there and we'll take breakfast. So that is called barrier and fence. So we are doing the work page wise. So now we for all threads, maybe for partial thread also we can. That's why barrier and fence is most important in synchronous and coordination. And this set of concept is very much important in multiprocessor and multi-threaded program. And sharing data, it need to be done through particularly lock-in and unlocking, mutual exclusion. Hardware instructions need to ensure the locking. And in Python, it supports byte level coding, TS and CS particularly. And we have a high level construct to do this thing. Internally, it will do. And why concurrency? First thing is simulating parallelism, even if we have a universal machines. And second one is performance. Most of the applications are parallel. Underlying hardware are parallel, multi-core. So why not to use concurrency? So you can simulate real world concurrent system on parallel machines. Okay, most of the applications are parallel. Underlying hardware are parallel. Even suppose you want to simulate human behaviors. At the time of saying I'm speaking, I'm thinking, I'm doing many things. Okay, so human body is a lot of things running in parallel. Suppose someone want to simulate the human behaviors or human things, then a lot of things need to simulate parallel. Okay, so why multi-core? Multi-core will improve the cost and power effective solutions. Because if you look at in hostel, boys hostel or girl hostel or whatever, institute hostel. Hostel you have some common facility and many rooms are there. Personal room is costlier than dormitory. Dormitory is very, very cheaper. The multi-core you can assume that there will be very less common space, but there will be common space and then there will be many dormitory or separate private space. Okay, so you can correlate multi-core as a hostel rooms. Hostel rooms. You cannot allocate a bungalow to each student. Bungalow will be too costly. You can say bungalow is a universal system. Hostel room with shared facility is sufficient, and particularly hostels. And whenever you share a lot of resources, right, you have a lot of what I can say available things. Need not to require high frequency to run. A lot of applications make easy to manage. A lot of applications easy to manage and easy to do cost-effective solutions. So this same things happens for high-end 5-star hotel also. If you go to any 5-star hotel, so they will create not 1, 2 rooms or 10 rooms. They will create 500 rooms, 700 rooms in 5-star hotels. They have common facility, very nice common facilities, and they will create huge number of rooms. Okay, because they can replicate, they can put many floors and do. Because it will be less costly. Even many multi-floor 5-star hotels are much cheaper as compared to many hotels because of that reason. What is the difficulty? So multi-core personal room is costlier than dormitory. That's fine, but whenever you are saying sharing many things, then most important thing is critical sections. We need to use log and barrier. Coherence. Shared data at all the places should be same. Shared data at all the places should be same. There are 4 interesting problems. LCCI. I mentioned in the first slide. LCCI. Locking, coherence, consistency, and interference. Coherence is shared data at all the places should be same. I have an example. Okay. Consistency. Order should be similar to serial. Another thing is whenever you are running multiple things, one will interfere with others. One processor, applications running in one processor will interfere with others because everything is shared environment. How to handle the shares? In government of India, we have this quota systems. So one set of people, they're sending more people than we need to give priority to the other guys. So this is the how people handle in real life scenario also. Okay. So one processor interfere with others. If one guy is sending more number of requests, more number of memory requests or hard disk requests, other people are suffering. And in that case, we should give some quota. So we cannot send more than this, or first let other people do the work, then only you are allowed. So in that way, people handle. So clearly 4 things: critical sections or log and barrier things, coherence. Wherever the shared data, all places it should be same. Suppose you have a phone number. Okay, you have a phone number, and your phone number need to be same wherever you have given to your friends. Suppose you have changed your phone number, you should inform all your people, or whenever they will call, so that somehow they will update their numbers. Coherence means wherever shared data. Suppose your phone number is shared data now, and whoever to whomever you have given the phone number, everywhere it should be same. Suppose you are changing, then everywhere it should update, or somehow they should get updated. Consistencies. Suppose you are writing a serial program and you are converting that serial program to parallel. So serial program output and parallel program output should be similar. Suppose you have designed an algorithm and you are converting this thing to parallel. So it's better to track the output. The serial output should be similar to parallel output. then it will be good. Standard C program and you have written a multi-threaded code, or Python program, serial Python program, and you have converted to Python multi-threaded program. So if whenever you are using multi-threaded code, you are getting different result. And it should not be. It should be same result, but it should be faster. Critical section. What is critical section? Particularly, means is there a shared object? Suppose any shared things is there. A particular value x or particular variable x or particular things is x or particular object is x is shared by many threads or many processes. If it is shared and doing some update operations, then at least one we should allow, not more than one. We should not allow more than one. Suppose writing to a shared variables, we should not allow multiples. Writing to hard text at a time, only one should get allowed. So that is a critical section. Before doing this, we lock, and whenever we come out, we unlock the things. So in hostel bathroom, there will be 3-4 bathrooms. There will be 3-4 bathrooms, but there will be 500 students or 300 students. But whenever someone goes enter to the toilet, washroom, in general they first lock. If they found it is locked, then they don't go to bathroom. First it needs to be unlocked. They will lock the bathroom. They will do their job, and they will come out. Whenever they come out, they unlock the things. Actually, same thing. If anything is said, then it needs to go through this procedure, lock and unlock procedure. And anything if you are doing any threaded programming or multiprocessor programming, this is most important thing to know, locking and unlocking. There is another thing is coherence. Value of x should be same everywhere. Suppose the variable x is in main memory, and in many processor the value of x is there. Suppose you have created a multi-process Python program, and a value is shared. Okay, you have value x is there, and it is shared by many processes. Okay, in this case it is processor I am showing, and when a processor shared data block, x is shared by multiple processor or process. Suppose x is modified at one places, that means it need to get modified at other places also. That means value of x, data x should be same everywhere. Otherwise you cannot say it is coherent. It is, you cannot say it is coherent. Coherence means the value of x should be same everywhere. What is consistency? Result of serial code should be same as result of parallel code. You are running the tasks in parallel, many tasks and many CPUs. Okay, and you are doing a serial computing. In same work you are doing in serially. Both results should match. Otherwise, how can you verify that parallel guys is doing correctly? There should be some way of checking the correctness. There should be some way of checking correctness. This should be correct. Okay. And what are the other difficulty? So many times, so people write sequential code, we know, but this lecture is for writing parallel, at least. Okay. And there are many autopilots tool are there, but they can do a very nice coding, but still it is in nascent stage. Good news is particularly CNN, DNN, Python parallel library is quite successful. Particularly NVIDIA developed a very nice high-level Python parallel code for GPU. And because of that thing, NVIDIA is popular, Python is popular. Python got popular in 2008-9 because they wrote very nice NumPy library, Panda library, and NetworkX. These are the three initial Pythons. And because of that library, Python got popular. But once the GPU and particularly NVIDIA graphics card came, at the time NVIDIA CUDA was popular, but CUDA was not popular. CUDA was there, but when they wrote parallel code for GPU or CNN, DNN, Python parallel lab, then GPU use got accelerated like anything. NVIDIA got popular like anything. Okay, so because that library. Another difficulty is scheduling. Scheduling in multiprocessor is very difficult. Even if a multiprocessor means managing and scheduling is very difficult. 4 taxes on 3 processor, it will exponential number of solutions will get. Even determining scheduling n taxes on two processor is NP complete problem. Scheduling 8 taxes on two processor, dividing 8 taxes on two subset with difference of their sum is minimized. This subset sum problem. And that means suppose you have n taxes of some execution time and you have 3 processor. Optimally scheduling on n taxes on 3 processor is very difficult. It's very difficult problem. Some heuristics you are there, you can manage, there is no issue, but optimally is very difficult. Let's with this, these are the what you can say pre-concepts we need to know before entering to the Python programming. Before entering to the Python programming. So if you have any doubts or anything, please let me know in the chat box. So if you have chat box, you can write the queries, I can answer. Let me see any chat box are there. If anyone can write anything.
Yeah, hello. Dear participants, if you have any queries, please let us know in the chat box section. Else you can unmute yourself also and directly talk with the speaker. Thank you.
And if there is no queries, then please remember, because my screen is already shared. So the most important thing is particularly these 4 points: critical sections, coherence, consistency, and interference. So we need to handle whenever doing any multi-processor programming or multi-threaded programming, we need to handle these issues. Or somehow some things get handled by Python library, some things get handled by OS, some things we need to. Okay, so sometimes we should know how to handle. Okay, we should know how to handle. Suppose some interference things are coming, or coherence issues are coming, or locking unlocking issues are coming, then we should be able to handle. Okay. So let's start with the Python multithreading. Okay, so we'll start the actual part of the multithreading code. Okay, so what is the benefit of multithreading? So whenever you do multithreading, so responsiveness increases. Okay, prevent a single long-running taxes from freezing the entire API. Okay, so in a Microsoft Word or any PowerPoint, so the software is written in multi-threaded by default. Because whenever you are doing some things, it will display, it will do the water checking, internally it will do the grammar checking. So many things it will do, and it will display very nicely. If something got stopped, then it will not be able to display if it is single threaded. So responsiveness prevent a single long running taxes from freezing from the entire application. Another thing is enable concurrency. Enable multiple tasks to appear to run simultaneously. Threads. Process have address space, share address space. So thread within the same process can easily share data and resources. Whenever you are sharing resources, it means we need to do carefully. Whenever you are sharing resources or sharing data, we need to do carefully. But sometimes we may require to share the data. Okay. So suppose only 10% or 5% of data is critical data for modification is happening. 98% or 95% is only reading purpose. Then sharing is a better way. Okay. So resource sharing, whenever I do, so communications overhead get very reduced like anything. And another most important thing is whenever you're sharing anything, So we should do any modifications or writing happens to a shared things need to go through critical section problem or need to be done synchronously. What is called synchronously? Synchronously or synchronizely? Synchronize means only one thread should get access at a time. Modification access, particularly write access. And benefit of threading is low overhead. Threads have less memory overhead compared to separate process. And Python multi-threading model provide the primary way to implement multi-threading in Python. So particularly Python have multi-threading models. We can say simple threading models. It offers a class like threads for creating and managing threads. And most importantly, synchronization primitive also available with the Python. Synchronization primitive like log and semaphore to prevent race conditions to ensure data consistency. These things are available. We can use it. Because this 4 point, synchronizations, locking, okay, consistency, and interference. This LCCI, this need to be, but among all, particularly locking is more important. Locking is more important from the user point of view. Okay, consistency, also coding point of view is important. Okay, but coherence and performance in generally, unless it is very high level, people don't give, and coherence is get maintained through hardware. Okay, so let's OS and hardware let's manage. Okay, so what is GIL? Global Interpreter Law. We know Python is a interpreter. C++ is a C++ Java is compiled language. Python is interpreted language. Python by default is read line by line and execute the code. So to enable Python multi-threading or threading, so GIL particularly Global Interpreter Lock. Python have one very important crucial thing that is called GIL, a crucial aspect of Python multi-threaded programming. What GIL do? GIL do only one thread can execute Python bytecode at a time, or Python, what you can say, interpreted code at a time, even on multi-core processor. What it says, even if you are writing multi-threaded code, but it will not run on multi-core processor. Not run means it will run only on one processor. It is bad for performance, but you can simulate multi-threading. This simplifies the memory management, but limit true parallelism execution on CPU bound tasks. What is CPU bound task? CPU bound task means suppose matrix multiplications. Matrix multiplications, inside matrix multiplications, we don't have a lot of IOs, input, output, or this read write don't happen. All our CPU get used very nicely. That is the CPU bound. IO bound means suppose you are doing a lot of keyboard or mouse event or this event in a program, have a lot of this event. Suppose you are doing a some editing operations, or downloading something and doing something, mixing up other things, and it is a IO bound. The CPU is not getting it. Okay, CPU is not getting used heavily, but all the rest of the things are getting used heavily. In that case, what will happen? So you can write multi-threaded code. So for IO bound tasks, for thread spend time waiting for external operations or keyboard operations or mouse operations or some disk operations, and simply the GIL switch to another threads. The GIL impact is less significant as that can release GIL to in IO operations, LL or the thread to run. So particular internally Python have, and it will try to manage. It will try to manage, and that's a good part of the Python multi-threaded program. Okay, but only bad thing is whenever you require more performance, then Python thread is not. Okay, because internally it uses single core. it's interpret only one thread can execute Python bytecode at a time. So that's the very bad part. Okay. So thread lifecycle, if you look at, whenever you create a thread have new, runnable, running, blocked, or terminated. So thread can be thread have already, because thread is a thread of executions. Okay. Whenever new thread get created is a new threads. Runnable means if you are assigning a task onto the threads and make it ready. Running means it is running. Block means it is waiting for some IO or something. Okay, or some block. Terminator means it executed and finished the thread. So new, runnable, running, blocked, terminate. So just like process also new, waiting, running, blocked, terminated. Waiting. So these are the process cycle, similar to that thread cycle also. So execution of threads. Suppose just hello world threads. Suppose whenever create a threads, in general what we assume that it's actually run with parallel with the main threads. Okay, it's run parallel with the, this is called thread create, then call thread join, and the thread joins whenever you call thread create, it created peer threads or parallel threads. Suppose in parallel thread we are printing some message, print HH, and once it terminates, and after that this main thread wait for the peer threads or whatever the newly created threads to wait for its terminations. Okay, in this case, so main thread got created a thread and called thread join, and peer thread got created, it did the work, and main threads wait for peer thread to finish the work. One finish that, again main thread start the rest of the work. So this is a simple example of multi-threading. So in multi-threading, if you look at the left sides, so left side part is, let me put the, so if you look at left side import threading. So this is a thread library. So import threading and import time we are doing. And in these things, there are two functions we are doing. So print numbers one functions. So for 1 to 5, we are printing that number. And whenever printing, you sleep for 1 second. Okay, so you sleep for 1 second. Another thing is print letter. Print ABCD and print for 1 second. The left side code, this green box have actually these things, two functions, print number and print letter, and each functions printing in 1 to 5. Okay, so it is printing the number, and in letter in ABCD printing the letter. And in the right side box, particularly orange box, what we are doing is actually creating threads. So T1 is equal to threading dot threads, target is print numbers. T2, another thread we are creating, threading dot threads, target is equal to print letters. In one thread, print numbers work is getting assigned. Thread 2, we are assigning print letters. Work is print letters or work is print letters we are assigning. After that, we are starting both the threads. T1 dot start, T2 dot start. That means what it is really happening, both the threads will start one after another, and the main thread will work. So wait for threads to complete, because there are two peer threads. In this example, we have only one peer thread in this case, but here there are two peer threads. So T1 and T2 are two peer threads. Okay, main threads create two peer threads, and now both the threads running, and main threads wait for both the threads to finish. First T1 and then second is T2. If you look at, this is the scenario. So this is execution of two threads. Okay, so one thing is hello world one. This is a hello world, but and once they finish, first print number will join to the main threads. Again, the print number thread or print letter threads will join to the main threads. So let me show the code in running the systems, Python systems. So are you able to see my screen, I hope?
Yes, sir. Screen is visible.
Yeah, screen is visible. So very simple example is, so are you able to see this thing? So you can see my screen. So import threading, then import time, and this is the first functions. So print numbers. Second one is print letters, and in each functions, what we are trying to do is for I in range 5, print number I, and then sleep for 1 second. This is sleep for 1 second. So here also we are doing the same thing, print a letter and sleep for 1 second. Here it is creating threads, creating 2 threads. Here starting 2 threads. Here creations don't mean starting. Creations don't mean starting. We need to put the thing starting. Q on the start. And here waiting both the threads to complete. Okay, so let's run the code. So what it will do? So it will run one thread. Okay, print something, then wait for 1 second. Both the threads will do parallel. So I can run this thing Python 3 pythread1 dot py. So if I do these things, you can see first every 1 second it is printing 1. Every 1 second it is printing. Every 1 second it is printing things. So I've run the things 2 times and it's happening. So let's come back to our code. So let's look at another example, vector sum example.
Sir, when it will stop? If after 1 second it is giving the output, so it has to stop at some time, no?
Yeah. So if you look at the code, so when it will stop, you are saying. So thread 1, we are saying it is actually done for 5 times. If you look at the code, so thread 1, for thread 1 for I in range 5, 0, 1, 2, 3 up to 5, 1, 2, 3, 4, 5, and second function have actually letter in ABCD. Both are doing for 5 times. If you want, you can change. Okay. Suppose if you do for one thing, if you do for larger number, suppose instead of this thing, suppose thread 1 let do for 10 times, then thread 2 will finish early, then thread 1 will do. Thread 1 will finish. Okay, so if I do these things, it will print 0A, 1B, 2C, 3C, and after that you will get a thread 2 is finishing quickly, finishing early. After 5 times it is finishing, and the first thread 5, 6, 7, 8, 9 is printing after that, because towards end only thread 1 is ready. So let's take another example, vector sum. So this is a serial code. So what we are doing? So we are creating data list from range 1 to 1000. This 10 to the power 6 plus 1, and total sum is equal to 0. What we are trying to do is actually we are summing all the numbers of a vectors. Okay, of an array, of an array. So total sum is equal to 0, and for I in range of data, so total sum is equal to total sum. Yeah, total sum plus I. So this one is total sum plus I. So there is a mistake. Total sum is equal to total sum plus data I, and we are printing the total sum. We are printing the total sum. And if you look at the things, so because for I in range data, so because for 10 to the power 6 number, we are taking a data and just adding, and these things can be done very nicely in parallel way. Suppose there are 4 threads you want to create and you can distribute the work. Then independently you can do the summations and you can accumulate later. Okay, so that thing can be done very nicely. Independently you can sum it for suppose 4 thread you are doing. Divide the whole data into 4 different range and you do the summations of each range separately in a separate thread. Okay, divide the work equal for each threads. Work per thread is total size by number of threads, and each thread they can do independently. And once you finish all the thread, at the end you can accumulate the sum. At the end you accumulate the sum. Vector sum in parallel, what you can do? So suppose data size is 100, you can divide thread 1 0 to 249, thread 2 250 to 499, thread 3 500 to 749, and thread 4 750 to 999. And how you can write the code for this? This is not very difficult. Okay, so the vector sum file. So what you are doing? Import threading. What you are doing? Import threading. Then this is the whatever earlier code also it is data is equal to list range 1 to this. Okay, so it will create a simple list of numbers. Okay, really. And this is how many threads you want. So number of thread is 4. Partial sum is equal to initially 0 into number of threads. Partial sum is actually what we are trying is data 0 into number of threads. 0 into number of threads are doing. And what every threads trying to compute the partial sum. Every thread is trying to compute the partial sum. What partial sum it is computing? So what about other things? The thread 1 is computing from 0 to 249. Similarly, here the total line is 10 to the 6. 10 to the 6 divided by 4. So each thread is trying to compute with its own range. Okay, start and end. So here this is a function. This function is compute partial sum. What is starting? What is end? What is index? Okay, so partial sum index. This is the what thread? What is the thread? Thread index. Okay, so what is the thread index? Partial sum index. Index is thread index. So if you look at it, so split the work among threads. So how much? The total length of data 10 to the 6. Number of thread is 4. Each thread how much chunk size? And now we need to decide what should be the range. What should be the start? What should be the end? Once you decide what is the start and end. So for I in the range of number of threads. Number of thread is, so if you look at in this case number of thread, this thread is array. So initially number of thread is 0, 0th number of threads. For 0th number of threads, you create a thread and assign which range you will do. So target is partial sum and argument is start and then I. So I is equal to 0 and then append threads. Once you append the threads, its number increases and then t dot start. Okay, number of threads is 4. We have assigned this number of threads is 4. So 4 times you creates threads and start it, and you give the work. This range you do, this range you do, this range you do, and this range you do. Our range is computed based on the index I. What is the thread number? Thread number 0, 1, 2, 3. So similar to this. Similar to this. Exactly similar to this. Thread 1, thread 2, thread 3, thread 4. Okay. So we created the threads. After that, wait for all thread to complete. So we have already started the threads. We have assigned the work and started the work. So in this loop itself, so for I in the range loop itself, we started the threads. After that, we are waiting for thread to complete. All threads were waiting for complete. So for T in threads, how many threads will be there? 4 threads will be there, and all threads serially were waiting for the complete. Okay, so we are getting completion message from the threads, and after that we need to combine the result, final reductions. Total sum is equal to sum of partial sum. Okay, so every thread I have calculated that 1 1. Now we need to combine all partial sum. So every thread have created their sum. Now we need to collect 4 numbers from each parcel sum, 4 numbers from each, and calculate the total sum. That is the final reductions. This method is called reductions. We are reducing all the number to a single number. We are calculating the total sum. This is sum reduction. It's called vector sum. We can do vector sum in parallel very nice. Okay, so let's run the code and see the output, whether it's doing or not. Okay, so vector sum.py, so you can see the code. Okay, so here the is a very smaller one. So this is a different code. So adding A is a vector, B is a vector, and we are creating another vector C, and correspondingly Ci is equal to Ei into Bi vector array. And here also we are defining start range and end range. Okay, because we are not doing the reductions, but in this case we are doing each element wise it is getting added independent. And here the code is exactly same. So here also we are dividing between the threads, work dividing between threads. Calling this is a t dot start. T dot start means we are starting all the threads after assigning the work, and this is waiting for all the threads to complete. Okay, joining all the threads. And once the all thread joins, that means every threads completed their work, then we print out the result. We print out the result. Okay, we print out the results. I think so. We have Python that array reduction is also there. Yeah, this one. So whatever the source code in the PPT, so the same code is here. This is a data range from 1 to 10 to the 6, and then this is number of thread is 4. This one is the calculation of parcel sum. This is the work, and work have 3 parameters: start, end, and index. Okay, and it is calculating the parcel sum. And this is a starting all the threads, and this is waiting for all the threads to complete. And this is calculation of final sum, final reductions. So if you run the things, so I'm using Python 3, and this total sum is 540 and 540. So this is and formula also can calculate. Okay, so the formula also can calculate. So this is vector sum. Vector sum can be done in parallel very nicely. Okay, this is threaded program. This is the threaded program, and in this code we don't use any locking. We don't use any locking protocol. We don't use any locking protocol. Okay, so because we're mostly shared data is not getting every data part is actually independent. Every thread is working on independent data. So that's why we don't require thread locking in this case. Okay, this is another versions. Okay, so using thread poolers. So what we are using here, we are using a particular package that is called concurrent.features, and from what thread pool executors. So there is a pool executors. So instead of creating thread every time, if you look at in this case, every time we are creating a threads. So threadings, we look at threading the threads. It create a new threads. It create a new threads. Okay, and it assigns some work. This is targeted parcel sum work. Create threads and assign work. Okay, but every time creating thread is sometimes may not be good. Okay, so if you create thread once and assign work, as many work at runtime, so that is better. Okay, so this is thread pooler. Thread pooler means, so we are not creating the threads every time, but thread is created once and then we're assigning work at runtime. So that's a thread puller, just like car pooling or this regular pooling. So thread pooling is some thread will be ready. Whenever they will get work, they will work. Whenever they will get work, they will work. Okay, thread pooling is like that. Okay, so this is what trying to do. So here, compute sum. The function is compute sum, start from end, and this is sum data start to end. Okay, number of thread is 4. Chunk size is length of data by number of threads. And what we are doing here in this case, we are doing it thread pool executors. What is the maximum number of worker? Number of worker is number of threads. H executor. So thread pool. So here we are creating 4 threads in a pool, and we are assigning work to the worker of the pool. We are assigning work to the worker of the pool. So these 4 threads are worker, and we are trying to assign worker or work to the worker. So executor.submit what functions? Compute sum I into chunk size. What is chunk size? Already calculated chunk size. This chunk size is total data size by length of data, then length of data, and this is getting which range of data we are assigning to do the compute sum. Which range of data we are assigning to do the compute sum. And for I in range of threads. So these things we are creating these things. Okay, and this is the total sum. After that, total is equal to sum f dot result for f in features. So features, in feature we are creating work, set of work, and result of features f dot result. After executing the functions, what result do we get? That is called f dot result. So features we are creating many work. Okay, in features we are creating many work, and once it gets the work done, okay, then what will be the result in that work? Result of the final result of the work, that is f dot result. Okay, so total is equal to sum f dot result for features, and after that you print the total sum. So this is the thread pool versions. Okay, what is thread pool? Let's run the thread pool version, then we'll come back to what is thread pool again. Okay, what is thread pool again? Thread pool versions. This is the same code, so no difference. Okay, so there is thread pool version of code. So in this case, this is compute sum. Okay, and this one is creation of thread pool with 4 number of threads. Okay, number of threads is 4, and here we are creating works. We are creating work and giving to the executor. Okay, creating work and giving to the executors. And this one is accumulating the result. Once they finishes, this is concurrent dot feature. Feature means you assign the work, and at the end you get the result. A result is integer or some kind of numbers, and that numbers after executing it store at some places. Okay, so internally it handles, and only you need to look at app dot result. Whatever the work they have created, feature work or to be completed work, at the end once they finishes, you just get the results from all the work and combine it. And what the combination? The combination is sum. Function is sum. Okay, let's run the code. So it will give the same results. You can see. Are you able to see same result? So you can see this result, total sum, and with the thread pool also we get the same result. But the thread pool also we are getting the same result. With the thread pool also getting, what is thread pool ultimately? So thread pool is every time you are creating threads is not good. So you create the thread pool and assign work. At dynamically you can assign works. So we'll discuss thread pool in detail. So another example is matrix multiplications. If you look at C is equal to A cross B, you will get if you take row of A and column of B, you will get Cij. Row of I and column of B, you will get Cij. A and B we are not modifying, we are reading from matrices. And Cij, each Cij can be calculated independent. Each Cij can be calculated independent. To calculate Cij, you require ith row of A and jth column of B. You can see the middle one is A matrix, right side one is B matrix, and left one is C. Okay. So for Cij calculations, we require ith row of A and jth column of B, and each Cij can be calculated independently. If you are able to calculate each Cij independently, then it's better each row of C. Suppose you calculate row of C by one thread, another row by another thread. That also can be. So very nice way is divide the whole row into T chunks, number of thread chunks, and each row, each chunk content n by T rows. Assume n by T is n mod T is 0. That means number of rows is divisible by number of threads. Just assume. We can do very nicely. Because these things is purely parallel. We can do parallelly. We can do concurrently. That's the good part. Okay. If you look at matrix multiplication serial code, how it look like? There are 3 loops: ijk, length of A, then iterate through column of B. Okay. This is length of B, iterate through row of B. Okay. So this is and for K, length of B is this one. AB. If you look at internal for loop are for B, external is for A. Okay, then result Ij, Cij is equal to Aik into Bkj. Actually, whatever formula we are writing, Aik into Bkj for Cij. So result Ij or Cij equal to Aik into Bkj. This is the serial versions. And what will be the parallel versions? Suppose this is for very smaller matrices we are doing, but it can be done for much bigger organisms. Suppose in this case, so matrix A and B, A is of size how many? So 3 rows, and B is 3 row 2 column. A is 3 into 2, 3 rows 2 column, and this is 2 rows 3 column, and C will be M cross B. Okay, so this is the and resultant matrix. This is row A is equal to length of A, column B is equal to length of B. What are saying? And what we are trying to do, so first we are import threading. This is defining the matrix. This is what should be the size of the C. What should be the size of C you are creating. Okay. And compute row I, because in this case, so if you look at C, so here is row wise is there. So 3 rows. Okay. So and here number of threads, how many you are using. So in this case, you can say number of threads based on the number of rows. Okay, so number of rows for I in number of rows, that many threads suppose I want to use. for each rows, I want to use a one thread in this case. And compute row ith row. This is compute functions, compute row functions. It take for only row I. It do for row I, and the functions compute row I for j in row column B, range column B. So it's do the Cij, and it's do for a vector dot product. So it take ith row of A and jth column. So one row and one column, it do a vector product, vector dot product, nothing else. Okay, vector dot product is each element multiplies each other and finally sum it. Okay, so it do the matrix ith row computations it doing it for a particular row. For each element we have a one vector dot product. For each Cij we have a vector dot product, and in a row based on the number of Cij element, it need to do that many vector dot product. Okay, and how many threads you are creating? We are creating number of rows of A. It is same as number of row of C also. It is same as number of row of C. Number of row of A and number of row of C is same. We get number of row of A and number of row of C is same. Okay, so M cross N and N cross P, it will result M cross P. So number of row of A and number of row of C will be same. Okay, so that's why in this place, in the second box, we're creating number of row of A or C, number of threads we're creating, and we're assigning one row to one threads, and we're append to the thread array, and thread is starting. And after that, we're waiting for the result to be completed. We're waiting for result to be completed. Once result is completed, then we can do the printing, print the result matrix. Once result is completed, we can print the matrix. Okay, so let's run this code again. So GI matmul actually same code, so no difference. So this is matrix creations, okay, declarations, and this is the compute row I. This is the compute row I, and this one is we're creating number of threads based on number of row of A or C, and we're tracking all the threads. What work is getting assigned? Target work is compute row with argument I. Okay, compute row is the work with argument I. It will do for ith row. This is starting the threads and waiting for all threads, and this one is after all threads finish the work, we are printing the result. This is what printing the result.
Sir, we can do matrix multiplication by thread programming also and without thread programming.
Can you repeat the questions?
We can do matrix multiplications by thread programming as well as without thread programming.
Without thread programming also can do. So this is how what I am giving is example of thread programming. So we can do matrix multiplication using thread programming, because if we do thread programming, so in Python it might not anyhow it will run serially, but if we do matrix multiplication using multi-process programming, then it will be faster because it will run on multi-core. So why you do threaded programming? Particularly, it can run in a multi-core processor very nicely or multi-process program. But in Python, thread is not for performance. Python thread is not for performance. Python process is for performance. Okay, but if you look at Java thread programming or C++ thread programming, so that is for performance. So what we are trying to say is you can do multi-threaded program for matrix multiplication. Very nice. Because matrix multiplication parallel code. Okay, it can be run in parallel. So inherently, all Cij can be computed in parallel. Python 3 MATML. So this after computations with 3 threads, each row were assigning one threads. So 3 threads is created, and each thread is computed by each row is computed by 1 threads in this case. Okay, so we have actually example using matrix multiplication using multiprocess program also. Not only multi-threaded, multiprocess. Where instead of 3, in this case, what we are looking at, this matrix size is very small because multi-threaded program in Python run in serial mode. It emulates the things. That whatever this thing first, this global Python interpreter GLI or GIL, that thing, global log interface, that thing actually it's make it serial. So that is not good for performance, but it can you can simulate the concurrency. We can simulate the concurrency. So Python threading may not be good, but Python multiprocessing is good for performance. Okay. So what is the Python code? Suppose we are writing Python code and doing some shared data modifications. Shared data modifications. So in this case, suppose we are running 2 threads, and there is a global variables. Counter is global variables, and you are doing increment in threads. You are incrementing a counter 10 to the 6 time. In this case, 10 to the 5 or 6 time you are incrementing. You are creating 2 threads. Each thread is incrementing the share counter 10 to the 6 time, 5 or 6 times. Then what will happen? Because counter is shared variables. Incrementing the shared variables without proper measures, it may give wrong result. It may not give, but it may give. Okay, it may give wrong result because we are moving data without locking, without proper handling. So that's why this locking is more important. Okay, so in this case, first one is, we will look at first box. It is a global shared variables counter, and second box, global counter shared variables who are modifying without locking. For underscore in range 10,000 means 10 over 5, and counter is equal to counter plus 1. Okay, counter plus 1 equal to 1, and we will get in this code. So it will have actually, it may give wrong result. Okay, it may give wrong result because anyhow in Python CLI, so what happens? It's run the thing serial mode, and if you run this code, you may get correct result, but it is not guaranteed. Okay, so let's run the code. So no lock counter. So the same code. So whatever counter is in this code, we are not putting the lock to access to modify the counter. And let's run the code. So what result you are getting? We are getting correct result because Python, that interpreter, thread interpreter is not doing very high performancely, and because of that thing, you are getting correct result. But it is not good idea. It may give wrong result. So that's why we should lock the share variables. We should lock the, because you are doing a very small work. Because you are doing small work, it's taking less time. That's why it may not get affected. But if you are doing a bigger work, that may get affected. Okay. So how to do locking or no locking? So let's look at the code. So whenever accessing a share variables, always use critical sections or doing the modifications in a proper way. So before doing the modification, you should log it, do the entry sections, and after the doing the modifications, doing the critical section work, or doing the modifications, you should unlock the log. Unlock the log. Okay, so there should be log variables. We should log it before entry, and we should unlock after finishing your work. The same thing, same example as bathroom, washroom of hostel. Okay, same example, washroom of hostel, a bathroom of hostel. Whenever you enter, if log is free, then only you should enter. Once you enter, log it. Before entering, you log it, enter it, do the work, and once you come out, unlog it so that other people can use. So this is the standard way of handling the shared resources. Okay. So with log, how we can do? So this is the declaring a create a log. Log is equal to threading.lock. Create a log. Okay. And before doing the modification, second block are equal to second red block dot red line block. So we are acquiring the log first. Once you get acquired the log, modify the counter and then release the log. Okay. First acquire the log, do the modification, then release the log. Okay. And the same thing can be done with very simpler way. So you create a log is equal to threading.log, and Python provide very high level syntax. You don't need to write log.acquire and log.release every time. But what you can do with log, do this modifications. With log, do this modification. That means it will take care of locking and unlocking. It will take care of locking and unlocking. With log, counter plus equal to. Okay, so let's see the example. How in Python code it happens. So this is the code for log acquires. Okay, this is the code for log acquires, and this is two threads running. Both are incrementing, starting the threads, joining the threads, and final count. So here also we are getting same result, correct result. First program, it may give the bad result, or it may give the wrong result. Okay. This is the with log. Directly you can write with log. You declare it. This is a create a log. Log is equal to threading dot capital LOCK. Okay. Then this is we're modifying the share variable by simply mentioning with log colon modify these variables, shared variables. And this is how we can do. This is a very simple counter variable, but suppose you are modifying it, not the simple one instruction, but very big file or very big things you are doing. Then it's always try to do with logging properly. Because this is the most important aspect of multi-threaded programming and multi-programming. Okay. So many threads trying to acquire the log. Suppose in earlier case there are two threads are there. Suppose 10 or 15 or 100 threads are there. Then this locking is a really critical thing. Locking is really critical thing. Sometimes you try to see the lock and then do the work. So in general, what happens whenever you go to bank? Suppose bank counters are too busy. Then what do you do? बहुत busy hai. Let's go back after some time. That kind of thing. Or go and check. But if it is too busy, then it's come back. There is a concept called try lock. Instead of simply waiting for the lock, you just try lock. Try lock means just check the lock. Check the lock. If it is busy, then do it after some time. Okay, so that is also another thing. Another interesting thing called semaphore. It is a Java code I am showing, but this concept is similar. So Python also has similar kind of semaphore thing. Semaphore means, so it is a high level construct similar to log unlock, but it can be work for not only the one or two, but it can work for multiple integer also. So whenever I say hostel bathroom, every bathroom have log. One can do log unlock. But if you go to a restaurant, suppose restaurant have 50 seats. That means If the restaurant initially it will be free and 50% can accommodate. If 51% can, then he need to wait. If someone leaves, then another person can enter. So that is called semaphore. It's high level construct and it have actually busy wait. There will be queue. If someone finishes, one guy can enter. Okay, so this is the binary semaphore and counting semaphore, integer semaphore. So this is binary semaphore. So if it is locked, if while s is equal to less than 0, busy wait, that means it is acquired by someone. Initially s is equal to 0, okay, means s is equal to available. S is equal to 0 locked, s is equal to 1 means available. Initially s is equal to 1. And if s is equal to 1, semaphore is equal to 1, that means you got the thing. If s is equal to 0, that means you wait for something. And whenever you're coming out, you increment the variable. That means you unlock the signal. Wait means you didn't got the lock. You need to wait. And signal means so you finish the work and you need to increment the. Okay, so this is for 10. Suppose in a restaurant there are 10 seats are there. Okay, so initially S is what I can say initially is to 10 instead of 0 values or 1 values. So in this case also, if 10 people are inside the restaurant, then you need to wait. If anyone come out, then he will signal, okay, now another person can come in. Okay, so this is the wait and signal. This is written in Java. In Python also we have similar kind of things. Okay, so let's take example of semaphore in Python. Okay, so in this case, what we are trying to do is we are creating a object with semaphore count value 3. Instead of this 10, s is equal to 10, 10 seats are available. Now I'm saying 3 seats are available. Okay, 3 seats are available. Count is equal to 3. Object equal to semaphore 3. Creating an instance. Okay, so let's create instance. The function is display name. Okay, this, we are calling a acquire method object.acquire. This is semaphore. Okay, object semaphore. We have actually what wait and signal. So in this case, acquire and release. So object.acquire for I is equal to 1 to 5. Print hello. Print hello and wait for 1 second. Print hello. Wait for 1 second. Okay. Print the thread name. Who is printing hello? So in this case, every thread is printing hello for 5 times. Every thread is printing hello for 5 times. Okay, whenever you print hello, you wait for 1, sleep for 1 second. After you do, you release the thing. So if you do this thing, what will happen? Okay, so suppose you create 5 threads, you create 5 threads, you create 5 threads, and every thread try to print 5 times hello. Every threads try to print 5 times hello. So total how many times? 5 into 5, 25 times print hello. Okay, but at a time the semaphore have count 3. At a time semaphore have count 3. At a time 3 can be printed. Okay, so let's see if you run the code. First run the code and then this is finalize the code. Okay, so Python. Okay, so this one is the code. Okay, so let's run the code. So this is the exactly same code whatever I've shown. So we are creating 5 threads and each threads print hello 5 times. And whenever it prints, after printing hello, it sleep for 1 second. Okay, and the semaphore have capacity of 3. Semaphore have capacity 3. At a time 3 can occur. That means after 1 come out, then the next guy can enter. After 1 finishes, next guy can come out. That means what will happen? What will be the expected output? Expected output will be initially 3 hello will be printed. Initially 3 hello will be printed. After that, 1 finishes, next guy will enter. That means 1 1 1 1 will continue. Let's see. Are you able to see? So initially 3 are there. This is for thread 1. So then after finishing, one guy will come out. One guy will come out. So in that way they will coordinate, and at a time always 3 threads can print hello at max. Okay. So after waiting, then only it is releasing. After waiting, then only who is printing and who is releasing can be figured out very nicely. Okay, so this is how semaphore works. So how suppose you want to simulate the restaurant, in this way you can do. Okay, so another interesting example is estimating pi using Monte Carlo. So this is a little bit of mathematical, let's see, but still it is a very interesting problem. Suppose you want to calculate value of pi. Value of pi, every people know that it is exactly you cannot specify. They can approximate using some values. And how to approximate? So suppose there is a this diagram shows a unit circle centered at 0. Okay, unit circle centered at 0, and there are 4, you can say, squares. In the positive quadrant of the axis, if you look at positive quadrant, xy positive quadrants, so half of the 1/4 of the circle is there. 1/4 of the circle is there. Area of circle is pi r square. Unit circle area of total area will be pi. If you take only positive quadrant, area of positive quadrant of circle will be pi by 4. And positive quadrant, this rectangle, area will be 1 cross 1 will be 1. Okay. Suppose you generate some random number between 0 to 1. Okay, x between 0 to 1 and y between 0 to 1. And this we generate randomly. Pick a random number n times, and m of those points point inside in this circle, because you are generating randomly. Okay, so if you generate infinite or huge number of time, then most probably, okay, most probably, so how many pi by 4 numbers of ratio, pi by 4 ratios will fall into this within the first quadrant of circle, this circle, positive quadrant of circle, positive quadrant of circles. So in this way, this probability, overall probability will be m by n, and m by n will be this area of positive quadrant of circle and area of unit square. This is m by n. N is total number of points. M is how many points fall inside the circle of positive quadrant of circle. Okay, from this, because both probability are same, m by n is equal to pi by 4, and you can calculate pi is equal to 4m by n. Okay, you can write multi-threaded code. So you can generate as many threads. If you generate more number of threads, more number of points you can calculate. More number of threads you can calculate more accurately. Okay, so this is you value of pi threaded value. So import threadings, import random, import time. Then let's do for 10 to the power 6 points, total number of points. Number of thread is 4. So per point thread is total number of point by 4. And inside circle you initialize with 0, and you create a lock because 4 threads are there. And at the end we are trying to do locking. Okay. So each thread what try to do. So inside circle is globally they are doing. Later on also can do, but as a first combine it, then you can do. Count is equal to 0, and for points, in points, for each case how many points? Very good. Total points is 10 to the power 6. For each guy they are doing points per threads. Here for in range in point, it's need to be maybe for each thread how many points you are allocating is here. So for each threads, point per thread is you are allocating. We are creating 4 number of threads. Okay, same procedure as earlier one, and here Monte Carlo pi target functions were given, and the target functions were generating two random numbers x and y between 0 to 1, and we're trying to check x square plus y square is less than 1 or not. If x square plus y square is less than 1, that means it is fall inside circle. If it is fall inside circle, then just add total number of points inside circle. If you look at this lower red box, who are doing after the what I can say for loop. After the for loop, you calculate all the things. After that, you generate for 10 to the 6 points, and how many points fall inside the circle, you count it, and at the end, every threads you increment the count. Okay, so inside circle equal to inside circle plus count. Okay, and at the end, you try to just estimate the value of y, because all things are independently doing, independently counting how many points, independently generating points, independently counting points, and at the end, the total count, how many inside circle were combining using a log. Okay, and from this we are trying to estimate the value of y. Okay, let's see in the program how it is getting estimated. Monte Carlo pi. So this is the log variability relations. This is the each thread trying to do the points. Okay, so total points, and this is the simple counts. Every thread trying to count how many points are falling inside the circle. This is xy generating within 0 to 1, and this is checking x square plus y square less than equal to 1. This one is after it counts for loop, it's just accumulate. Every thread accumulate to the final global variables with log. Okay, and this is the estimating for m by n. So this is 4m by n, this calculations. 4m by n, this calculations. N is total point, n is inside circle, and this is finally printing. Oh, Python 3. We need to use Python 3. And it takes time 0.12 seconds, and pi is equal to 3.140. So if you put more number point 3.142 and or more accuracy you will get. Okay, so this is the Monte Carlo way of estimating the value of pi. More number of points, more accurate the results. So thread pool. What is thread pool? Already we have discussed one example. Thread pool is a pool of worker threads that are managed by executor service, and this is idea of reusing the threads rather than creating new thread for every task. For smaller threads kind of thing, it's fine, but if you are doing bigger thread level programming, then it's better to use thread pool and try to reuse the threads. Okay, instead of creating new threads. This can significantly improve the performance of applications by reducing overhead of thread relations. Okay, this is I took this picture from Wikipedia. There are task queues, and threads are already created. You assign the tasks to a thread, complete it. Next task assigned to a thread, complete it. Whenever a task completes, the threads comes to thread pool. So that means if thread is working, then it's fine. If it is not working, you get a task from the task queue. Okay, so there's a very simplistic way of pooling the threads. Okay, so this is the simple example of Python thread pool. So suppose you want to download many files from internet, and parallelly you want to. So download files. So this simulate of downloading a files. So download a files. So suppose file ID you give and download file ID, sleep for some times, and finish downloading. So this is very, we're simulating downloading, not actually downloading. And you create submit 10 taxes, and here we are creating pool of 4 worker, pool of 4 threads, 4 worker, and we are creating 10 work and we are giving to the thread pool, and queue of 10 work we are giving to pool of 4 threads. Okay, and it's a simulate all file downloading, and after that we are trying to print the result whether all have done or not, nothing else. So let's simulate this thing. Oh, no, it's just not that. So thread pool. Yeah. Yeah, this is a thread pool. Okay. So if you look at this is simulating download files. Okay, and this is creating the thread pool, and this is assigning all tasks. Task is download file. 10 download file tasks are assigned to 4th thread of a pool. Okay, thread pool as a executor. Okay, there are 4 worker and we are assigning 10 tasks. So it is simulating when file downloading. So if you look at, so started downloading, some are finished downloading. So this is a total 30 lines will start, finish, and result. Start, finish, and result. 30 lines will be there. And they are doing this work as a thread pool. So 10 work were given, and every time a work finishes, new work from task queue comes, and if new events are 3 threads get assigned the work, and it start work. That means you are not creating the threads every time. Thread is ready. Whenever task comes from queue, it started. And whenever task get finishes, the free thread get entered into pool. So that's the thread pooling. Okay. If you look at parallel programs, so this is serial, any programs, all part is not means serialized or not parallelized. You can have some parallel sections, some serial sections, and given a programs, you will not get full parallelisms or execution time will not reduce infinitely. Suppose you are having a program which runs for 100 seconds, and if you run for on a 10 core processor, then you may not get actually 10 times speedups because your program may not have all parts parallelizable. Okay, so that's why that is called the Andel law is there. So we are not going detail about this. Okay, but speed up is always less than number of processor everything, and sometimes it is much lesser. So if you run on a single core and if you run on P cores, then speed up will be always less than P. And in general, it depends upon the how many serial part is there. If serial part is very huge, suppose a program run for 100 seconds and serial part is 50 seconds run in serial. So whatever number of processor you use, so you cannot reduce the time less than 50. That means you cannot achieve more than 2 speed up. Suppose program run for 100 seconds, serial program. And if you want to parallelize it, serial part is 50 seconds. That means if you run infinite number of processor also, the total speed up will be less than 2. Because 50 times, 50 second time, you need to run serially because that is not parallelizable. Okay. So that limit. So this says if it is serialized code, is that in this case, if you look at, so this is actually 500 total amount of work is 500, but 200 amount of work is parallelizable. Even if you use infinite number of processor, because parallel part can we make it to 0? You have infinite processor, but serial part is still, it will lie. So speed of achieve is 1.7. Okay. So we're skipping some things and let's move back to very interesting topic called Python multi-programming or multiprocessing. So difference between multi-threading and multiprocessing. So threadings, it's run on the same memory space. You thread within a single process. But the most important thing is affected by the GIL. The GIL, this locking. Okay, so global interpreted locking. So particularly these things is only one thread execute Python bytecode at a time. So that's actually very bad. But best for IO bound. Suppose your file operations and network requests are there and you can switch to other things, then it's fine. But what is the pro? The best part is lightweight. We can do share memory, no need for inter-process communications, faster to spin up. Very fast, very lightweight. Cons is the only thing is it can be harder to debug due to shared state and state condition map. Multiprocessing. Each process has its own Python interpreter and own memory space. Uses multiple processors. And if it is a CPU bound process success, you can get huge amount of benefit because this is Python interpreter, particularly JL lock interpreter, if not required. It bypasses that. Every process is own Python interpreter and memory space. So it's true parallelism you can do. Better CPU utilizations, no JL interface, but it is heavier, slightly more complex to coordinate because RPC, IPC you need to do. Okay, but here the good part is you can utilize the multi-core part of the CPU. You can take benefit of true parallelism. That's the most important thing. Let's take example of multi-thread and multiprocessing. So here, instead of creating thread, we are creating multiple processes. From first line is from multiprocessing, import process. From multiprocessing, we are importing process. We are defining function square of n, and what I'm saying, if underscore name is equal to man, process number is equal to 1, 2, 3, 4, 5. And for other process, okay, for n in numbers, create a process, append the process, start the process, and wait for the process to jump. So this second boxes, if you look at second set of boxes, this is run in, what can say? This is run in main process. This is run in main process. Okay, this is run in. If underscore name, this part run in main process. If you look at square functions run in other process with some parameter, some argument. If underscore name is main, if main process, then the functions, code of the functions under the main, it run on the only main process. In other process, it run square. Which square is global, other process also can. Okay, so this is, if you look at this multi-program code, code is same. Which part will run on which process? Suppose you are creating 5 process, main process plus another 5. Main process will run the if underscore name is equal to main. The process name is main, then it runs this part. Okay, so we'll try to run this code. Other process will run with the target function is square and with argument n. Okay, and n in number. What is number? Number of 1, 2, 3, 4, 5. That means the main process is sending data one by one to each newly created process and give the target functions. And they will execute the target functions with the particular number or particular argument. Let's run the multiprocess example. So here number of examples are very less. Okay. So you can see the same example. Okay. So this is with pool and example 1 with alternate. This is the what I've shown. Okay. So this is the all process will run, and this is only main process will run. This part only main process will run. So we are getting multiple processes. Same code running on multiple processes. So here, if main process, if the process name is main, then this part will run. Other process, this part will run. Okay, so then main also it can run this thing. Okay, so but main is working and waiting. Main will not run. Okay. Anyway, main is not executing the square. So let's run the code. So you will get it for 5 processes and run on different processes. The same thing can be done with Python process pool also. Not only the thread pool, we can do it process pool also. Okay. So this is for process pool. So same code, we are doing it process pool. So we are creating a pool of process with multi-processing pool, number of processes 4, and in the pool you try to square functions, and argument is from numbers. Argument is taking from a number array, and functions target function is square, and everyone is doing 1 1 1. There are 5 numbers are there, 4 processors there, one will get 2. So let's run the code. Are you able to see? So process 1, process worker 1 squaring for 1, 2 squaring for 2, 3 squaring for 3, 1 is squaring for 5, and 4 is squaring for 4. Because there are in array we have 5 numbers and number of processes 4. Main process is running. Main process is running. Main process is coordinating process. Main process is coordinating process. It is creating another 4 process. Okay. So similarly, so this something I've seen. We can do vector sum parallel and multiprocess thing also. Okay. So you will look at vector sum. So multiprocessing import process value array CPU count and import C types. What we are trying to do is do the partial sum vector sum. In the partial sum, what are thing? Create a local sum. Then within the its own range, start to end, do the local sum. Put the result in IDX. IDX means result array. Result array of current process ID. Result array of current process ID. Just like thread ID, this is local process ID. Okay. And here same thing is happening. If main functions is distributing the array, main function is distributing the array. Okay. Number of processes CPU count. Means you create CPU count based on how many processors in your PC. Partial result, it is doing partial result is equal to array, C types, and doing is putting the log is equal to false, and chunk size equal to how many processors you are creating, and it's creating number of process based on number of CPUs we have. Okay, number of CPU count we have. It is creating that many process and waiting for the result. So main function is main process is coordinating process, and other process it is doing the work. In result array, if you look at result array, it is in particular IDX. Okay, IDX means process ID. It is storing the local sum. It is storing the local sum. Okay, and if you look at, so what it is this doing? So at the end, so total sum is equal to sum plus partial result. All partial result is getting. With partial result, you are getting from different number of process. Array, C types, num process, log false. This is you are getting the different from different process. Okay, so this is partial sum, partial result. Sum is equal to sum partial result, and total sum is equal to doing all the things. So here, so if you look at after doing the things, after doing the array, this partial result, if you look at array C type, double, num process and log. If you look at this thing is what? After finishing that, this is doing the things. It is called initially, but at the end it is doing. At the end it is doing. Partial sum happen. After that, every partial sum are giving a file result. Okay, so in each process that result is there, and it is not on only one process. The result ITX is actually with that array, everyone give back the results. Okay, so in that way, you can compute the vector sums in multi-process environments. Let's run the code. So whatever the thing, same thing we are doing here. The vector sums, partial sums. This is CPU count. This is the each worker what are doing. This is waiting for this thing. No, it's look different code. Large vector sum. Yes. So this one is the actual one what we wanted. Okay. So this is the main process. It is doing if it is main. This is shared array and result container. It is inserting the result container, and this is working of process, and this is waiting for the process. And this is only main functions execute. The author functions, worker process, they execute this part. So same code, but some part executed by main function, some part executed by worker, and they coordinates. Let's require Python 3. So it will compute the things and compute the total sum, and it will do verification also. So NumPy verifications it will do the compute sum. So it will calculate with NumPy and calculate with parallel versions, and it will verify the result. So whenever you're doing serial version and parallel versions, the result should match. Serial version and parallel version result should match. That I told you. So that is called consistency. Consistency. What is the meaning? Consistency. Serial version and parallel version result should match. So NumPy is calculated the same thing, and whatever I calculate also almost same. Okay, so almost similar accuracies. And you can do the same thing for matrix multiplications. Okay, so with matrix multiplication you can do. So this is serial version of matrix multiplications, and if you are doing for the parallel versions, we can create shared ABC shared, and then number of processes will count. Same things here, parking of processes here joining, and here convert back from the result NumPy result and print the result. Okay, so here what we are doing, we are trying to create multiple processes and running the program to multi-process program. Okay, so let's see this multi-process program. large MATML. If you look at this is a large MATML program, the SAM code. Okay. This is worker multiply, and this is A dot set, B dot set, this one. And these are the process creations and process joining. And this is converting back the result and printing. This is converting back result and printing. So it is because of large one, so it's taking time, but it is doing the result correctly. Okay, so what we are discussing is actually you are doing multi-threaded program, multi-process program. We're done with actually locking, unlocking. Okay, we're doing a semaphore. So how to do semaphore in what you can say in thread, and then so how to do multi-process program. Okay, here in multi-process program we have not done with lock and all the things, but it is almost similar. Okay, so here also we have log and unlock programs. Okay, so particularly how to share data manage. Here in general share data we do a message passing. Exact locking unlocking may not require through message passing we do. Okay, so MPI style programming is required. Okay, if you know more about the multi-processor programming or multi-process programming, MPI is a good source of doing the things. I do research in actually multi-thread program, multi-processor program, multi-threaded architecture, and cloud computing. So I can give you a lot of detailed idea about this particular topic. Okay, so thank you. If you have any questions or any queries, please let me know. So is multi-threading or multiprocessing possible in C++ and Java? Yeah, multi-threading is possible in C++ also. So most of the multi-threading started with actually C++. Earlier Python was meant for actually serial programming, not for multiprocessing. They later on they added. In Java also it is possible. Thank you.
Yes, thank you so much, sir, for this wonderful session.
Yes. So I'll share the slides and code with our team. So
yeah, it was nice session. Thank you.
Sir, hello. Yeah, hello. Yes, sir. So on behalf of Professor Gaurav Trivedi, sir, I thank you, Dr. Aripita Sahu, sir, for taking time from a busy schedule and accepting our invitation to be a global coordinator for this program and also for taking this lecture today. Thank you, sir.
Thank you.
Dear participants, with this we come to an end of day 4 of this program. So we have already launched the attendance of day 3. So we request you to kindly check it out. And please note that all the participants should be connected for the entire duration of the class, that is from 10 to 2, in order to get proper attendance. If you join for 10 minutes, 20 minutes, 30 minutes or 40 minutes, your attendance won't be considered as present. Please keep that in your mind. And also we request all the participants to please, whatever is your queries, please let us know in the WhatsApp group, okay, which we have created for this course itself, and personal messages won't be entertained from now onwards. And also we request all the participants, tomorrow will be the first MCQ from 2 to 2:30 p.m. So all the participants are requested to be please online during that time. If you are not able to connect from a system, you can connect from mobile phone. The MCQ will be conducted in Google form. So we request all the participants to please make yourself available for that time for half an hour, so that you can attend the entire MCQ for certification purpose. So for those who have academic load and everything, they can email. Okay, we have already provided you the email ID. So we request you to kindly email over there. So that's it from our end. In case if you have any queries, please let us know, or else we can wrap up the session. Thank you. Yeah, Rekha ma'am, there will be 20 questions as informed earlier only. So for 20 questions, we will be providing 30 minutes. Yeah, it's not possible. We can understand Amit Tiwari sir, but whole lecture you can't attend, but at least try to attend halfway at least. At least 2 hours or more than that. But please note that attending only for 30 minutes won't be considered as present or less than that. We will not reveal the threshold over here. Okay, but we at least want the participants to please join for half the class, at least one session from 10 to 12 at least. Yeah, Ankit Kumar sir, we are trying to get the codes of yesterday also. Once we receive, we will be surely uploading it in the drive section. However, if you don't get the code also, we will be uploading the recording of the class. From the recording itself, you can get the codes. Okay, because in the recording, the screen is shared and everything is visible. So from the recording, you can note down the codes. Aruna ma'am, the exam will be from 2 to 2:30 p.m. Dhanalakshmi ma'am, the topics of the MCQ will depend upon the syllabus which has been taken till today. So you have all the materials with you and at least the recordings are there. You can prepare yourself. Today's recording will be uploaded by 5. Yeah, email ID I have already provided, Ashish Kothari. Arnav sir, we are in touch with the expert. Once the expert forwards, we will be surely uploading it by evening. Thank you. However, video recording will be uploaded. That's for sure. If there is any slide not available or code not available, you can get it from the record. So that's it from our end. I guess all the queries have been resolved. Okay, remaining queries, whatever is regarding the attendance and everything, you can WhatsApp. Okay, after the lunch time, every queries will be solved. Okay, so that's it from our end. Thank you, dear participants, for connecting with us and cooperating with us and making this day 4 of the program successful. Thank you all. So we request you to please log off from this link. The meeting link will be deactivated in another 2 minutes. Thank you.